So this long-term guidance, unfortunately, is not provided by most people in the outside world. I mean, I don't know, genuinely, I don't know anyone who actually provides a long-term guidance to researchers in Africa. What happens most often is that people from places like Europe and North America, they go to Africa for short terms, like a couple of weeks or up to a month, and give short courses. And they think that they solved all the problems in Africa by doing that within a week or two or month. But it doesn't solve anything. I mean, it doesn't solve anything with respect to the people in Africa. The only thing is that the people who are going there getting most of the benefit in terms of, I mean, I shouldn't say this, but I may get into trouble for saying this, but these people, when they come back to their home countries in Europe or America, they use this as evidence to get promotion, right? So the people who gets most out of these trips are the people doing the trips, not the researchers in Africa. I mean, as I said, the researchers in Africa need constant daily guidance, and I am providing that 365, 24/7, right? And as I said, there are tons of problems they face. It's not that they're not hardworking or anything. They are as hardworking as anyone in Europe or Americas, but they have, as I said to you already, there are so many problems they need to go through, including lack of resources, teaching load, no guidance. That's the most important thing. There's nobody to guide them on what kind of problems to work on, right? So that's the most important thing. If somebody listening to this workshop from outside of from either Europe or from Americas, please try to do what you can to help the researchers in Africa, right? And that's all I have to say. And if somebody likes to discuss something about what I have said, you are most welcome. Hello. If you can also use the Akiju, can you talk, please? Akiju.
Okay. Good afternoon.
Good afternoon.
Yes. Good afternoon. Yeah, I'm with you. Thank you. Okay. Is it? Okay. You want me to say?
Yes.
Okay. I'm just saying hello to everyone. So, I just joined the workshop.
Okay.
So.
Okay.
Yes.
I'm just talking about the purpose of this workshop is to inspire researchers in Africa to work on important problems and try to publish their finding in international journals, and above all, try to get people from outside of Africa to guide them, guide researchers in Africa to work on important problems, because one person cannot do anything. I mean, I've been doing this for many years. As I said, I've been doing this for many years, and quite a few papers have been published jointly with researchers in Africa, but I alone cannot make a lot of difference. So if others listening to this from outside of Africa, if they can make a difference by working with people in Africa, that would be much appreciated.
Thank you. I don't know if I can just make a comment, a contribution about the
Yes.
discussion.
Yes.
So, first of all, I like to appreciate the organizer for this workshop, and for also bringing some of us on board to also share our experiences and also to share our research findings. So, but most importantly, just as I've said, that there are quite a lot of challenges that we face. Those of us that are here in Africa, and I will say to a large extent in Nigeria. One of the points you just mentioned is where you have those in academics have to take large classes in a semester. So
Yeah.
that it's not, I think it's a peculiar issue to almost all the schools in Nigeria, in Africa, where you
Yes.
have somebody taking, for example, for my own side, like in this semester in my university, I'm taking like 4 courses. And these
Yes.
4 courses, I have a class that you have students running into 1,000. So
Yes.
you have to teach over close to 1,000 students in a
And
particular class, and then you have to grade this number of students. So you have to assess them, grade them, and so you ultimately at the end of the day, you discover that in a semester you are not productive. You barely can
exactly.
do any good research.
Yes.
So
And
that's a big limitation. And secondly, even when you strive out of your way look to do one or two research, funding is also another problem.
yeah.
Because, for example, now I had a paper I want to publish, and I have to pay like $300. So
Yeah.
my income as a lecturer in Nigerian university in a month is not up to $150 in a month.
Yes.
So if I'm going to publish a paper, just a paper with about $350, $500 in just one paper. So that
Yes.
means I have to sacrifice my income for 4 months for me to
Yes.
publish just a paper. And
Yeah.
so yeah, that is suicide. So that
Uh,
is one of the it's a challenge that we face, and
uh,
even to get research funding, collaboration. A lot of times you have to work all alone, because
yeah.
even your colleagues, when you work with your colleagues, when you get something as a research output, you have to push it out for publication. But it's a difficult stuff. So
And
I think this, among other things, one of the issues that we face, and so when we have this kind of opportunity to share our experiences and to also to listen to other people, so it's a big opportunity, and we always appreciate that. So I hope
yeah.
at first that we're going to have a lot of
Yeah.
take home from this workshop. Thank you.
Uh, Thank you, brother. I understand that funding is a big issue in Africa. I mean, it's nearly impossible for anyone in Africa to get funding to fund their research, whereas people from outside, they get funding to do research using data in Africa, and the benefit goes to mostly them, not the researchers in Africa. So we need to change that. Let's work together. Yeah. The
Please.
Hello.
Yeah, hello.
Yes, brother. How are you?
Yeah, thank you very much. I am from Cameroon.
Yes.
I also thank all the organizer of this conference. I hope that it will be a starting point
Yeah.
in order to collaborate with all the colleagues overseas to
Yeah.
have funding in
Yes.
order to help us to develop research.
Okay.
And in the funding, if we can, we hope that tomorrow We will have students with the scholarships. You know, here in for example, in my country, students have to pay school fee, and sometimes you have good students coming from poor family. After bachelor, it is difficult to family to take student in charge in the master cycle.
Okay, brother. I think we need to move on. We need to move on now. We have a presentation by.
Okay.
Yeah, we will talk later, brother.
Thank you very much.
We have a presentation by Eddie Dyer. Is he around?
Yes, I'm here.
Hello, bro.
Good day.
Good day.
Yeah, good day, everyone.
Can you make your presentation, please?
Okay, yes.
You have about 25 minutes.
Okay. Okay. Let me see. Just a minute, please. Okay. Yeah. Good day, everyone. My name is Adedayo Adepoju. I am from the Department of Statistics, University of Ibadan, Oyo State, Nigeria. I want to welcome everyone to this year's Black Heroes in Statistics Research Workshop. And I also want to thank the organizers for inviting me to be a part of this workshop. I appreciate the opportunity given to me to make a presentation at this unique and wonderful workshop. Thank you very much. In fact, I was delighted when I received the invitation. And I know that this opportunity to deliberate on the issues of Black heroes in statistical research in Africa is a very beautiful one. And I know that firstly, it is to honor our past heroes, you know, in the field of statistics. And secondly, is to assist young statisticians in their advancements in this field of statistics. Yes, I will follow this outline. Of course, in today's data-driven world, application of statistics in everyday life is ever present and is a reality. And of course, it touches every aspect of the society. And you know that people make use of statistics without even knowing it. The market women, the journalists, everyone talks about statistics, but they don't even know that it's statistics they're actually communicating when they are discussing. And I'm sure that in the nearest future, you know, people will, people without statistical literacy will be seen as illiterate. Okay, so statistics is a very important field. And everybody is now, you know, enjoying the efforts made by our past Black heroes. Now you will notice that later on, you will see it in this presentation that I have several Black heroes. Several heroes who are not non-Blacks. Now the reason is not far-fetched. When I was doing the research, I noticed that when you type famous statisticians, they will bring people from Europe and the Americas, and you hardly see anybody from either Nigeria or any African country. And so that's the reason why you will see that the list that I have there of the famous statisticians are basically those who came from the from the UK, and those who came from the US. Okay, so now I want to, if you look at this, you will see this is Frederick Goss. He was a German, and he was a renowned mathematician. And then, of course, he developed interest in the field of statistics, and particularly in the area of probability theorem. He was the one that pioneered the establishment or the development of method of least squares in his days. The next person is Florence Nightingale. She was an American, and although she was a nurse, she also developed skills in data collection and statistical analysis. And she was prominent. In fact, she was the first female member of the Royal Statistical Society. And then she was the pioneer pioneered the development of data visualization. In the Crimean War in 1854, she was prominent in the analysis and the data collection of a study, because she found out that, that the conditions surrounding the soldiers were likely more deadly than the ones that they incurred during the battle. And then she did that by using the polar area diagram that she developed. Carl Pearson, made great contributions and advancements in statistics. And then, emphasizing correlation and curves. He also created the chi-square distribution, which is now widely used by everyone, and the method of moments. And he did other very novel works in his time. Now, Gosset was a British, and he was also a renowned statistician. Gosset was, not in the field of statistics, because he was merely the head or brewer of Guinness beer. He had no statistical background, but then he played a pivotal role in developing the student distribution that we are used to now, while ensuring the consistency of hops in small batches. He came across, he developed and pioneered the T distribution. Now, Fisher was a British, and he was also well recognized as a trailblazer alongside Carl Pearson. And in fact, his work in statistical design included advocating for randomization in experimental design. He also authored a book in 1925, Statistical Methods for Research Workers. And he also developed the maximum likelihood estimation method, which is used for estimating statistical model parameters based on observations. We have Gertrude Cox. She was the first female American, she was the first female recipient of the Iowa State master's degree in statistics. And then she also established the Department of Experimental Statistics in her days. Demi was an American, and she was one of the notable American statisticians in his time. Of course, he was renowned for his expertise in systems. He also played pioneering roles in quality improvement, offering consultation to leaders and engineers during the World War II. Turkey is a very popular name that we all know, and he was an American, and he had diverse contributions to the field of statistics. Okay, so he was renowned for his robust methods, innovative graphing techniques, and the creation of the widely used Buck plots that is used in time series and other areas in statistics. Of course, he was the one that developed the exploratory data analysis, which is now commonly used by students and researchers in statistics, and even outside statistics community. is Turkey HSD test. It's frequently applied in analysis of variance for multiple comparison procedures. That is to assess significant differences in means. There was a quote by Turkey, that is widely known and widely said by people, that the best thing about being a statistician is that you get to play in everyone's backyard. What does that imply? It means that every discipline, no discipline can excel or can be can thrive without the use of statistics. So you see that even in languages, they make use of statistical tools. So it is very important that statistics is important, that people know that statistics is very important. Now, George Box was a British, and he was originally a chemist, but he became a statistician during the World War II. And he was instrumental to the development of the Box-Cox transformation, that is essential for the normalizing of non-normal variables. Now, there was also a quote by George Box, and the quote states, essentially, all models are wrong, but some are useful. But some are useful, which is, which means that not all models are correct, not all models are okay, but of course, you see majority of the models being useful eventually. Now, Janet Norwood was a British, and he was the first female commissioner of the US Bureau of Labor Statistics in 1979. She also pioneered the development of the Consumer Price Index and the employment metrics. Now, interestingly, we have a South African here, Dr. or Professor Danny Craig. He was a South African, and he served as a statistician and a mining engineer, in South Africa. And he developed the geostatistics in his time. He was a professor in the University of Witwatersrand in his days. And this method, Kriging, bears his name. For those who are familiar with the method, it was the one that pioneered the development of that method. We also have another South African here. His name is Herbert Sichel. And he himself and Craig worked together. And this man was prominent in the areas of both theoretical and applied statistics. He was the one that developed the Sichel T estimator for log normal distribution statistics. And of course, he did some other wonderful works in the areas of statistics. Of course, like I said, mentioned earlier, and you'll notice that the first 10 individuals that I mentioned were from outside the African continents. And of course, I identify with the problems or the challenges faced by the African researchers in their days, okay? Because in the mid-80s, when I was an undergraduate in the university, I discovered that all our lecturers were trained outside Nigeria. And few of them came back to Nigeria to work, and others left the shores of Africa, for greener pastures. And one of the things that I noticed at that time, as young as I was then, was the fact that they didn't have many teaching materials. They had limited teaching materials to teach us. In fact, in most cases, they didn't even introduce us to any textbooks in statistics. Okay, so we were only making use of the notes given to us in class. Okay, so this is one of the problems that I think the Black heroes faced in their time. One of the challenges that they had. And then towards the late 90s, when I was doing my PhD, I discovered that we only had one computer in my department. And, we were many that were on our PhD program at that time. And, what can you possibly do with a computer? in a department. We didn't even have access to internet connectivity at that time, because internet connectivity came in to Nigeria around 1999. Okay, so in fact, only few people were able to afford it. I had to take a loan. I had to take a loan to be able to get my first phone at that time. So you see that they had, so you can imagine how much work they would have been able to do at that. They wouldn't be able to do much because of these restrictions and challenges. And then, of course, there was a time I was looking for names of my lecturers in some of the journals that were available at that time. Some of these journals were dominated by foreign articles. In fact, not a single African was in most of the journals. You know, all the articles written in the journals that I had access to at that time were, you know, the articles were published by foreigners, by foreign authors. You know, so this comes to the point that they had issues, they had challenges. And the libraries were also filled with old textbooks. In fact, most of the textbooks were mathematics textbooks. And then there's this problem of forced marriage between statistics and mathematics. When I was growing up and when I was in school, we used to have department of mathematics and statistics. In fact, in most institutions in Nigeria, we only have mathematics and statistics department. In other places, you have mathematics and statistics and computer science department. So mathematics and statistics was not seen as a course. It was seen as a you know, topic under statistics, under mathematics. You know, this is the reason why even those who left secondary school, when they get into higher institution, the first time they had any interaction or any knowledge of statistics is when they enter the institution, okay? Because the little statistics we did in our undergraduate, during the school certificate or the secondary school was just part of the mathematics syllabus. So it was really a kind of challenge for some of us. Okay, like for example, myself, I didn't know anything about statistics until I got into the higher institution. It was when I got there, and in fact, most of the people that found themselves in the statistics department were basically those who could not gain admission into the other fields. So when they failed to get admission into other departments, they were transferred to statistics because, of course, nobody applied for it. And so to have people in that department, they will just transfer people, students into that department. So you'll see the student not doing very well eventually. So I've mentioned the problem of brain drain because of the way, because of the way that the governments in our continent here, you know, the way they handle issues regarding education. I read sometimes, you know, I read something recently, I read a report by the University World News stating that most African countries spend barely 1% of their GDP, you know, on research and development. And this also affects those in the field of statistics. Okay, so these are some of the problems that we have. And I think that we need to have the right mindset and we need to have the right attitude towards finding solutions to some of the challenges that we are being faced with in this part of the world. But we have so many opportunities now. Okay, one of the opportunities is what we are doing today. This is a kind of collaboration. Now we know each other. There are people from different countries, you know, in Africa that are present at this workshop. And so we can collaborate together, we can discuss together, we can discuss issues, we can even do articles together, we can do a lot together. And then there are also grants now available, travel grants for people. Before COVID-19, there were several grant applications that we wrote and we got. But after this problem of COVID-19, in fact, even the Americans and the Europe, they are no longer giving grants to anyone. Okay, so it's difficult to access travel grants now. And then, of course, there's also opportunity of writing proposal for projects where you will be able to access grants. At the beginning, it may be very difficult to access these grants, but with time, you will be able to access the grants. You may not be the PI at the beginning, that is the principal investigator, but you can be a member of the project committee. And then you understudy the way they write proposal. You can even go for proposal writing skills. That will help you to be able to to excel in the field of statistics. Now, of course, you can also join international bodies like the American Statistical Association, the student chapter. There is a student chapter for those who are students amongst us here. And then there's the Young Statistician meeting, and there's a caucus of women in statistics for women in statistics. Okay. Of course, regional and national bodies are also available for us to join. You can also get people who can mentor you. I know that Professor was talking in his opening remark about this. So you can get people, because in our own time, we didn't have people who could mentor us. So we were just forcing ourselves to do some things on our own. But these days, you could get professors who will be available to mentor you. And then you can attend international conferences and workshops that will help you in advancing in this field. Now, what is the way forward, or what are the ways that you can use to develop yourself in this area? You can acquire skills and competencies. Okay, you can do this on your own, or it can be done if it can be advocated that internship program be made compulsory for undergraduate students. We do that in our department, and it helps a lot. This program will help you to be able to make use of the theory that you were taught in class. You can use it. You can be taught the practical aspect of it. And this is a very innovative way of developing your skill also. Okay. And then instead of waiting till the final year before you introduce the applied statistics courses in our institutions, our tertiary institutions, one way of encouraging and helping students will be to introduce applied statistics at the very beginning. Okay, because you will see a graduate not knowing how to make use of any method in statistics. It's very sad, and it's not very good. Okay, and people don't give, they are not careful about this. Okay, so, and then another thing is you have to be current in that area of your specialty. The area of your specialization, you need to be current, know what is going on in that area, know the new trend and everything. And then there is this, I don't know whether any one of us have come across the Laboratory for Interdisciplinary Statistical Analysis. This is a good platform for us to make it as statisticians. We have it in our department, and it's a global network. And Professor Eric Vance happens to be the one who initiated this laboratory, who started it when he was at, I think, one polytechnic at Virginia Tech. Yes, Virginia Tech. He was a lecturer at the Virginia Tech when he started this Laboratory for Interdisciplinary Statistical Analysis. We should have over 40 laboratories now across the continent. Okay, so it's a very good way of teaching students how to make use of the methods. In fact, in our department, we have interns who are here for 1 year, some are here for 3 months, some are here for 6 months. In fact, in some cases, after they are done with their internship, they are still around. In fact, one of them came for his service in our department. He finished in around January this year, and he's still in the department. Because now they can do analysis, they can do a lot of things. They get works from abroad, they get works from even the Americas and Europe. they get work that they do, and they get their money from it, you know. So it's a very good platform for development and for acquiring skill in the area of statistics. They are taught how to design questionnaires, how to carry out surveys, how to make use of statistical packages like the R package, like the SPSS, the Stata, and the rest of them. Okay, so for those who, yes.
Daya, I think your time is.
Oh, okay. So for those who are interested, I have my email address on the first page of the slide. Thank you very much for listening.
Thank you. Thank you for your inspiring talk. Any questions or comments? I agree with you, Dio, that one big issue is the funding. It's a big issue, but we need to keep making applications and hope that it can be successful in the future. But in the meantime, as I said before, I'm happy to mentor anyone in Africa 24/7, 365. So any kind of help you need, please feel free to contact me. And hopefully others will be inspired by this workshop to provide support for researchers in Africa.
Okay, so just to add to what Sarah has just said, and also to the presentation by Professor Adepoju, I think nowadays the dynamics is changing in that, in terms of the funding landscape, there's now it's more or less like mandatory in some instances that people from Africa are the ones that are placed as principal investigators on most of these projects that relates to Africa. And I think that is a good development. It's an important development and it's a good one. So these are the things that we should look out for. And I think in that regard, that will be able to put some of these things we are looking at in perspective. Thank you.
Thank you, Manuel. Any other comments? Okay, the next presentation is by Siaka. He's from Burkina Faso. You may know that's one of the poorest countries in Africa, yet there are people in that country who are genuinely interested in doing research. I'm not sure if he's around. Siaka, are you there?
Yes, I am connected.
Okay, good to hear from you. I got your PowerPoint slide. If you want me to share.
Did you get the last one I just sent like at 12 o'clock?
Yes, I did.
Yes. This one you can share this one, please.
Okay. Just a minute. All right. So this is Dr. Siaka. He is from Burkina Faso, but he also has an appointment at AIM South Africa. Okay, over to you, Siaka.
Thank you very much for inviting me for this conference. I am very glad to be here today. So, as you said already, I am Siaka Luge. I am a biostatistician at the Institute of Research in Health Science in Burkina Faso, but I'm also visiting lecturer at the African Institute for Mathematical Sciences in South Africa. But I'm also, are you hearing me?
Yes, yes, I am.
Yes, I am also a part-time lecturer at the University of Ouagadougou in Burkina Faso. So the topic I am going to present to you is Bayesian approach with informative and non-informative priors for the modeling of social issues. Case study of divorce among women population in Burkina Faso. I should say that being a researcher at the Institute of Research in Health Sciences, many people come to me with several questions, and from there I can pick up the need of the use of Bayesian methods and the deep understanding of what is it. So that's why I came up with this topic. I found it very important to help people to know the importance of Bayesian, how it can improve our analysis. Okay, next slide, please. So for this presentation, we are going to first of all present a short background, methods, results. For the result, we are going to present a frequencies approach. After, we are going to present the result of the frequencies and the Bayesian non-informative. And after, for the Bayesian informative, we are going to make conclusion and some references. Next slide. So Bayesian method has a potential of improving quality of estimates. But non-informative priors in Bayesian approach led to same result as classical statistics. That's what many people think. But in reality, we say similar results. It led us to similar results, but not exactly same results, okay? So when you use a Bayesian method with non-informative, you will get similar result as the classical statistics, but not the same result. And because we used to think that it will lead to same results, people usually many people will prefer the frequencies approach when they don't have any prior knowledge on the study they want to undertake. Also, good quality informative prior seems to be complicated to obtain and also to justify the use of a certain informative priors. That's among the reasons why Bayesian approach is still viewed as complicated and only accessible to high-skilled statisticians. For this reason, the use of Bayesian in social and behavioral study is still very low, especially in the context of Burkina Faso in developing countries in general, and especially in the French countries. I need to add that Burkina Faso is mainly French speaking country. So English is something we learn during our research period. Okay, so for the methods, we use demographic and health survey of 1998, 2003, 2010, and 2011. And then we use the software Winbacks. Classical regression was used to model the divorce for the data from 2003 to 2021. And afterward, we use a Bayesian approach with non-informative prior using the 2021 data. And later on, the Bayesian approach with informative prior this time using the 2021 data, but using previous data as a prior for the informative priors, okay, to build up our informative priors. Now, for the next slide, please. So since we are studying divorce, our population was split in two groups, those who were divorced and those who were still married. And then, so we use a logistic method. The general formula of our posterior is probability of beta given y is equal probability of y given beta times probability of beta. So the probability of y given beta is the likelihood, which is well known in this case, where delta I here is the probability of success, which is exponential of xi beta divided by 1 plus exponential of x transpose beta. And for the prior, we use betas, a normal distribution. So we use the normal distribution, and this is the formula we wrote below, probability of beta. And then, no, fine, you can, yeah, so now we got our posterior, we multiply the prior with the likelihood. This is the long formula we got for the posterior here. And when we got our posterior, what we do, we use a Markov chain Monte Carlo. Okay, this is used to simulate numbers following our posterior distribution. So in our case, since we use the Winback software, Winbacks work with the Jeep sampler, because when it comes to Markov chain Monte Carlo, we have mainly Jeep sampler, Metropolis Hastings, these algorithms which can help us to run the Markov chain Monte Carlo. So in our case is the Jeep sampler we used, and we use a 95% credible interval to make our conclusion. But we ensure that our Markov chain errors were less than 5%. And also we ensure that the history plot and the density plot show convergence. We also ensure that the Gelman, Rubin, and Geweke diagnostic convergence show that our Markov chain has converged. And finally, we make sure that there were no autocorrelation. So that to present the method, how we implemented the analysis. Now, as a result, here we present the results from using the 98 data, 2003, 2010, and 2021 data. You can see that the place of residence, rural, is significant throughout, right? Every year, this data was significant, as well as the total number of children ever born. It was also significant throughout, and the trend was also the same. Other variables such as age start to become significant in 2003 and follow in 2010, all right? And so on for the other variables. Next slide. So place of residence and number of children were significant from 1998 to 2010. The trend was the same. Women in rural areas were having less probability to get divorced than those in urban areas. And the probability of being divorced decreased with the number of children when the number of children increases. And in addition to the place of residence and the number of children, age and religion were significant in 2003 and 2010, but the age was consistent. The probability of being divorced increased with age. This was the same, but for the religion, there were changes. Christian women were less likely to get divorced than Muslim women in 2003, but we found different opposite results in 2010. Next slide. Okay, so now when we did the Bayesian non-informative priors compared to the frequentist simple logistic regression, we found similar results. All the variables were significant, and the estimates were quite similar, only that if you look at for primary, for classical, the estimate was 0.42. And for using the Bayesian with non-informative, we found 0.28. So here, this change is quite a, a, a big difference. Not so big, but the difference is there in the estimate. And if you take the odd ratio, you will find that it make really real change. So is to show that Bayesian with non-informative and frequencies give a similar result, but the final result is quite very small change. This is like an increase in the quality of the estimate. Can we go to the next slide? The next slide, I'm just presenting briefly the history plots as well as the density plot to show that our 10 were converged. You can go to the next slide. So finally, findings show similar result between frequencies approach and Bayesian approach with non-informative priors. All the variables were significant, okay? But we really insist on the word similar, but not exactly the same. Okay, next slide. So based now on the data from results from the data 1998 up to 2010, we found that age, place of residence, and total children ever born were consistently significant with the same trend. So we use it as an informative prior this time. So to do that, we took the mean, the average for the estimate, and the pool variance for the variances to set up our informative priors for the next step. Okay, but variables which were not significant, we kept the non-informative priors as the priors for them. Next slide. So in the next slide, you can see that using the Bayesian with informative priors, all the variables are still significant again, but the estimate also, you have some changes, right? You can see in the logistic, in the classical result, you have minus 0.82, while in the Bayesian you found minus 0.91, and for total children ever born, you found minus 0.54 and minus 0.47 for the Bayesian. So these results are not exactly the same because we gain in improvement of the result. Okay, next slide. So in conclusion, the results show that Bayesian method with non-informative prior provides similar results that, like the classical statistic method. However, previous studies showed that for small data sets, classical statistic and Bayesian statistic can lead to very, very different results. Okay, so in conclusion, the study suggests the use of Bayesian approach to improve the quality of the estimates, even though we are using non-informative priors. And the introduction of informative prior lead also to a slight improvement in the estimates. Next slide. Okay, so for the wide use of Bayesian in the general community, there is a need to improve the algorithm because we spent like 1 day and a half to get our result when we run this code in Winbox. And there is a need to improve the algorithm to be a bit faster. And there is a need also to show more case with example of informative priors in social and behavioral sciences. Also, there is a need to make Winbox software more user-friendly, as well as the result output, since we need to type the results we obtain from the software. It may bring or incorporate some typing errors. And we should show to the general community that Bayesian approach is not a frequentist approach for small sample size studies. Many people think that when you have a small sample size, that's where you should use a Bayesian approach. No, Bayesian approach is not for this. It's completely different way of analyzing data, and we need to emphasize of that as well. Next slides are just some references of some documents, some articles I wrote with my PhD student. Yeah. So
Okay.
yes, thank you very much for listening to me. I am done. Thank you, and ready for your questions.
Thank you, brother. Very interesting talk. Any questions?
Yeah, I have a question. I'm interested in the social aspect. One of the results states that Christians, most of them are more prone to divorce before 2010, but it switched roles after 2010. So I'm wondering, what in reality plays the role? Because divorce is less in African countries than in the Western countries, definitely. And we need to really, because of our culture and tradition, we are more holding on to family values. I wanted to find out, this switch, is it caused by like social media influences? Or what would you say about that?
Fiake, are you there?
Yes, I am there. Okay. Thank you. It's a good question because this is like one part of a big research on divorce because we have it was a big project on divorce because last year in Burkina Faso, it was the first time we got a very big level of divorce. It was so high level, we never accounted it. When we say very high level, okay, in some countries we will say it's still small, but for us it was quite a big number of people going for divorce, and it came to the municipality registers. Many things can explain that is the way of getting married. Everything starts from how you get married, right? The way you get married is the same way you get divorced. So in the past, when people used to get married in our setting in our countries, there were high level of cultural involvement. They need to go to the village. Many people will get involved. But nowadays, many couple will stay in the capital city. They will get married, and when they have to divorce, it is quite simple as well. I need to mention that here, divorce is for those who were formerly married or those who separated are also counted in the divorce here. Because in our country, divorce as divorce at the municipality is not enough to measure the level of what is happening. So we incorporated also those who got separated, okay, traditionally. Okay, so these were also incorporated. So for me, the main reason from our big research we did, there were social components, there were people who were doing qualitative analysis. We found that the first thing is the way people get married. And as you can see, rural areas, divorce is quite low because they are still continuing these traditional weddings. And then divorce is quite low in these areas. Okay. And nowadays also we have many people getting divorced because of a problem of infertility, right? This is quite common in cities because we have also a high level of infertility is also increasing. We are now up to 10% of couples. You see, this is quite high. In the past, it was almost 0%, right? And these are city things. It's happening in the big cities. So this is what I can say regarding your questions. But somebody wrote a question, is Winbacks free? Yes, Winbacks is free. It is free. It is
Yeah.
free. You can just download it.
Can I come in, please?
Sure. Yeah.
Regarding the use of Winbacks, I remember when I was doing my MSc at University of KwaZulu-Natal. Yeah, it takes a very long time to run a code, especially when you have a lot of risk factors or predictors in the model. But then I got to realize that there is this also package, we call it INLA, Integrated Nested Laplacian Approximation, which is implemented in R, and that is much, much faster. And there is also a package to it, which you can easily use it even if you are non-statistician. So once you understand it, you can easily apply it to the data. INLA is very fast. I don't know if you have tried that before. And then regarding the social aspect, in statistics, there is this, people say there is significant difference, p-value, if it is less than 0.05, and there's a lot of argument as to, in the medical field, people don't really even want you to base your conclusions on the p-value, but rather to base your conclusion on the magnitude of the effect rather than the p-value. The same way, if you come to the divorce cases, to measure whether the divorce is high or it is low. In the field of statistics, usually sometimes we produce the results, but we are unable to kind of relate them to the social aspect or the public health aspect. And this is where the need for collaboration comes in. In the public health they may have cutoffs that can say that, okay, for this country, when there is this number of divorce cases, then we can consider that as high, or we can consider that as low. I don't know if there is such definition, or maybe you may need to follow up with the necessary authorities so that they can provide a guide as to how to define high in terms of divorce and then low in terms of divorce and so on. Yeah, thank you very much for that wonderful presentation. I really enjoyed that.
Thank you.
This Bayesian is a lot of debate in the UK. Some people don't even want you to mention that you want to do Bayesian, especially you want to do your PhD study. You said, okay, I'm interested in working in Bayesian methods. They'll tell you, I don't. So there are some people who don't even want you to talk about Bayesian methods. There is a big debate, and I'm so happy that you are going in the direction of motivating people they need to use Bayesian methods. Of course, they are completely different methods, and what Bayesian can do, the frequencies cannot. Thank you very much.
Okay, thank you, sir. Dr. Abdul Karim.
Yes. I'm sorry, I'm speaking from Ghana.
Okay.
Yeah.
Hello. Do you have a question?
Let me lower my hand now. No, I was the one just
okay.
okay.
All right. Okay, sorry about it.
So the INLA, have you tried before?
Abdul Karim, Dr. Abdul Karim, thank you very much for your comments. I'm also very happy that you say you did the University of KwaZulu-Natal.
Yes. That's where I had my master's from. Then I proceeded to the University of Cape Town for my PhD.
Yeah, I was a lecturer there from 2014 out to 2018.
Wow. Okay.
Yes.
I left there in 2013 or 2014 rather. Yeah.
Yeah. So I was a lecturer there, and I was lecturing Bayesian statistics at Westville campus. So you see where we met now. That's very nice. Okay. Yes, I know INLA. I know so many software to run the Bayesian statistics, Bayesian analysis. I even used to run also JAX and many other software. I know it very well.
Yes.
It is in purpose I went to the Winback software. and I will explain why. Now they incorporated Bayesian in Stata, you know,
Yes.
this Stata software, yeah, to make it easy for people to run the Bayesian analysis.
Absolutely.
Even the latest SPSS try to incorporate also Bayesian components
Yes.
to make it easy for people to run it. But I went to Winbacks because I think like Winbacks did not improve much since the beginning, because
Yes.
at the beginning Winbacks was the one we were all using. I went to Winbacks because of that, and also because of the flexibility Winbacks got to make to incorporate so many things in your model. Okay, but for this kind of simple model, it is true I could have used Stata, SPSS, JAX, INLA, and so on to run it. Yeah, so I'm aware of that. Yeah, but it was making purpose also for Winbacks to improve, because I feel like it is more flexible than the others. That was the reason. Now, what you say for the general community, you are completely right. Usually we do our analysis, we will publish papers, and we stay among ourselves, and people are even scared of what is happening, and the result need to be taken out. And also regarding the discussion about Bayesian analysis, many people are against it, even the statistical community.
Oh yeah.
Yeah, that's why me, my specialty is Bayesian, so I am really advertising and showing to anyone. So I use this platform to say to anyone who wants to use anything in Bayesian and you need any help or something, me, I'm only working in Bayesian, apply in many, many other fields. So I'm always open for that. Okay. Thank you very much. Okay.
Thank you.
Yes. Thank you very much. I think before we go for the next talk, let me just make a very quick comment about the issue of the Bayesian stuff. I don't think people are completely against it, especially in the UK. I mean, practically everyone in my department does things that relates to Bayesian statistics. And in fact, I have to supervise PhD students doing Bayesian analysis. I think the real problem is that when we have to deal with complex problems, the elicitation of prior, a lot of people miss this aspect that, because in this source paper, these people have used this kind of prior, this is what I'm going to put on my, that I'm going to use, and then I'm going to get a result. And at the end of the day, some of this result becomes very meaningless. So that is the reason why some people appear to be skeptical. But there are aspects, for example, if you do things in, regularization techniques, for example, you have problems of uncertainty quantification. And most people will want to go in line with Bayesian analysis to do uncertainty quantification. So people really don't have problem with Bayesian analysis per se. I think people have problem with how people use Bayesian techniques. So that's what I just want to add to that.
Okay, thank you, Manuel. The next presentation is by Angela. She is a freelance journalist in South Africa. Her presentation is entitled "Take Charge."
Hello, all.
Hello, how are you?
I'm good. I'm now taking charge of my split screen function, which I never ever can get right at the first time. So just bear with me for a moment.
Yeah, take your time.
Okay. Can you see that?
Yeah, we can see you.
Can you see me, but can you also see my first slide saying, right, research ID?
No.
We are just seeing your desktop.
Yeah, which says researcher ID. Can you see that?
Yes.
Next photograph is that of a gentleman with a baby. No.
Mm.
What are you seeing at the moment?
Someone looking into computer, or what is that? Wearing
A
robes?
man with a baby?
We're seeing a couple of things on your. We're seeing research ID. We're seeing a PDF copy. We're seeing a guy with a phone and at a computer.
I
That's
think
okay.
you open a folder, you open your folder, black
Yeah.
statisticians. You open a folder, black
Yeah.
statistician.
Yeah. I've done that, and then now I can see on my screen. Sorry, that's the one thing I've never been able to really grasp is how to do my slideshow. So I'm opening up my slideshow.
I think one thing you could do is just share the whole window. So if you do that, then everything you
Yeah.
click is seeing what you are doing.
If I
Yeah.
share my window.
Everything. So if there's nothing to, yeah, that's.
Okay. Can you now see my PowerPoint slide?
No.
I think
Still
it's
not?
Think it.
Sorry.
Not
I'm a
just,
writer, not a.
can I
No,
suggest that
PowerPoint.
you bring this down first, then try to share your whole screen, and then start
Okay.
clicking through. Yeah, so you could just start.
Okay, I'm going to start again. I'm
Yes.
sharing my screen, and that's the one I am. And now?
Yes.
Yeah.
Yes, we are
Great
there.
stuff. Always my biggest part of my stresses. Okay, hi. My name's Ingela Divenaar. Thanks for your patience. I am a freelance science writer from South Africa. I have been working in the field for the past 25 years. I've had the privilege of meeting Quinsley in Germany recently, and that's why I'm here. Thank you for the invite. I really appreciate it. So I work a lot with researchers, and she thought that I should maybe chat with you about how you can take control of your message. So you are all working in your fields, doing some form of research, teaching, doing various things, and you all are doing your thing, and how you can roll that out better and tell more people about it. Because in the end, if you don't tell people about it, no one's going to find out about it. People very seldom come to you to ask you about your research. There is a proactive step that you need to do to put your research out there. And I have found over the course of my work here in South Africa, but also now broader, I work for Nature Africa. Also, what I've found is once you start putting your word out there that you are doing research, either through your university outlets or through newspapers or things like that, once you start doing that, when funders go look at your profile, they start, and you are able to tell them that you have this or that from papers out. They find you online, and they like seeing people in the media. And I often find that funding leads from media presence or a social media presence. But one thing, I've often worked with scientists, and one thing that I find people struggle with is to really understand what their research ID is. What's your researcher identity? So you could go out there and start marketing your journal articles and things like that. But it's really important to me that you know what you do. And with that, I don't mean that you don't know what you do. I mean that you are able to tell that to other people in such a way that they, within 30 seconds, can grasp what you are doing. So it's late in the mid afternoon. So let's play a little game. I want to let you think about who you are as a researcher, and that's really an important part because that also will structure your thinking around your social media presence, about your presence in the media, newspapers. So who are you and where do you want to be seen and what do you want to be known as? So let's do it. Let's do a little thing. So let's do an exercise. You don't have to unmute yourself, but do you know what this person, maybe you can if you want to play along. What do you think is this person's career? What does this person do? It's pretty obvious that person is a doctor. Yeah? That person, what's that person's job?
Eye specialist.
Absolutely, yeah. That person is a
Ophthalmologist.
cricketer.
Okay,
Yeah.
Rugby.
Yes, really not a horrible pair of pants, but otherwise he's a cricketer. And that person, photographer, né? That's easy to know what people's jobs are. So if they go into a party and they have to tell people, what am I? What someone asks you, so what do you do? It's easy for them to say what they are doing. People understand that. What I found interesting, so this lady is a viticulturalist. So she works with grapes and growing of grapes. Becomes a little bit more difficult when you go into the sciences, that I find. So he could be anything from a virologist to a microbiologist to a food safety specialist. Now, if you had to draw a picture of what you do, just, yeah, have a thought about that. If you have to draw a picture of your job, how would you do that? Yeah. And if you had to say who you are and put that on a t-shirt, would that be, is that how you sell yourself? I'm a statistician, so to save time, let's just assume that I'm never wrong. That's a bold statement. I'm not sure if you ever use that, but I googled statisticians images, and these are the t-shirts that I got. I don't know if you've done that exercise before, but sorry, I'm just looking where my other t-shirts are. There's that one. I like that one. Quinsley, I'm not sure what you think about that one. And then there's the more logical options. Not as funky, but is this how you think of yourself? Now in South Africa, we have a game called 30 Seconds. It's a game that you have to explain words without using the words, and you have to do this within 30 seconds. And that's something you also have to try to do for yourself. Can you explain what you do and where you do it and in which field you work within 30 seconds? And can you do that perhaps without saying the word statistics? So if you're a ballerina, the game works like that. If you're a ballerina, you can't use the word ballet. If you're into transport, you can't use the words transportation or transport. So yeah, does anyone, okay, so let's try this guy. So what does he do? He is a tennis, oh, I can't use the word tennis player. I can use the words, he uses a racket and a ball, he plays on a court, and Roger Federer and Serena Williams are really good examples of him. So that hopefully will get you to the fact that someone's a tennis player. If you say someone is a wait, if you want to, you have to describe the word waiter. So it's someone that goes he works in a restaurant, he brings you your food and your bowl and your drinks. And hopefully someone will be able to, but can you describe your job in so few words? Does anyone want to take a stab at how you would describe your work and what you do? Because I really believe that it's an important thing. If you want to do communication and you want to strengthen your portfolio and you want to strengthen your ability to reach people, funders, government officials, you need to be able to define yourself. You need to know who you are, what you stand for, and sell yourself. I've shown you that. So I went, what's interesting is if you Google statisticians, if you Google that, the images that you get, these are the top images that I get on Google. Is this how you see yourself? Is this how you would, I asked the question because I don't know. Is these are the top 7 images that I got. Is this how you do your job? I'm asking.
Not really.
Yeah.
Is that, yeah, but that's how the world sees you, right? So you need to it's irrespective of where you are in the world. If you're in Europe or you're in Africa or in America, that is how the world sees your function in these images. So you need to take charge in a way. Can you think of how to visualize your job? Is there a, yeah. So these are, I only have a half an hour, so I'm rushing through. But these are the stuff that I want you to maybe start thinking about. This being the first such workshop that you are hosting, which I really am honored to be part of. Yeah, so Harry Potter asks, I'm not quite sure who he asked that, but who are you? And can you in 6 questions, maybe if you're at a party, if people come to you and say, so what's your job? You know how people are. I can say I'm a journalist. I write about other people's research, and I write stories about them. So that's kind of easy for me. But sometimes even people don't understand what research is. So it's about the words that you use, and what's important is, very importantly, be clear who you are first, not who other people want you to be, but who are you first? What do you do? And also very important, what's the difference that you make? So often people want to know, so yes, you're this or that, but what difference does your job make? So for instance, does your job add to better policy? Do you help people in COVID times to make better decisions about health aspects? Whatever what would you, what is the difference? Quinsley, I'm sorry, I'm going to use you often as an example just because I know you. But she works in climate change. So she wants to make a difference about how climate change funding is being accessed and distributed. So she knows, and you didn't always work in that field, but currently that's one of the fields that you work in. And so that's the difference that you want to make. And also, why are you working in the field? Why did you choose what you are doing? And also within the why question is also stuff about why did you choose it initially, but why are you still in your field? It's very basic, but very important. And maybe I'm a bit more philosophical than you thought I was going to be, and apologies for that. But think of me as your mental coach for the day. Yeah, so people really often they want to know what people do, but why? What's the difference that you make? And I think it's an important personal exercise to go through. And when you describe your stuff, try not to be too technical. You know how it is to describe to your siblings what you are doing. I still struggle. But yeah, keep it short, keep it simple. People are more interested about the why and how. They don't really want to know which computer programs you use. They want to know why. And if they are really interested, they will do follow-up questions. Now, they always say you have to have an elevator pitch. Elevator pitch is anything between 30 and a minute long, depending on how many stories you are able to be in a lift with when Bill Gates stands next to you and is potentially interested in funding your project. You only have a minute. How do you sell yourself? So always, I'll also send this presentation on to you, but This slide I got from SciDevNet, which is a wealth of information. And these are important questions to ask yourself, because you don't always have the same message to everyone. Know who you are talking to, make it relevant and relatable, and have those starting lines. You don't have to always memorize your whole speech, but have a few lines, catchphrases. And if you have a story to tell, that's now if people seem to be interested in what you are doing. Bring elements from the story, bring stories, examples, give people examples, and then they know what you are working on. But make them understandable. Try to avoid too much jargon. Don't talk to people the way that you, as a fellow statisticians, talk to each other, because you understand and at your core you understand each other. But I didn't have mathematics I didn't even have matric mathematics, so I will be lost. So understand who your audience is, and sometimes you need to have a type of slogan for yourself. What's your secret sauce? What's your secret element? What makes you stand out? What is your one-liner? So I think it's important that you can be able to sell yourself in 30 seconds, in 1 minute, and sometimes you also need to sell yourself in really just one sentence. And that's sometimes all you have to get people to take you seriously and ask further questions. So those are the type of messages that one would be able to work on. It's about explaining yourself well, easily, and clearly. And once you can do that, you can sell yourself and your research findings. Yeah, so before heading out, so there's many communication opportunities. So yeah, so this was one of my key messages, I think, is that you need to know who you are, what you stand for, what's the type of research that you work in, and why do you feel that your work is important. That's very important, and I think everyone in each type of career actually needs to go through that type of exercise. Sorry if I'm rushing, but I only have a few minutes left. If you are communicating, so there's many opportunities where you can feature your research. So this is all about how to broaden the horizons, how to get your message across to a wider audience, not only in your university, but also further afield with other researchers, and then also further to people in other continents, funders, and etc. So conferences are always a great opportunity, and use them. Don't be shy to pitch your abstract. It's being proactive is the most important thing. So if there's a call for a conference, pitch your abstract. It's a way of getting your voice and getting your messages out there. Sometimes you won't always be, sorry, I'm Afrikaans and sometimes I forget my English. Sometimes your abstract won't be accepted, but you never know how the fact that you did submit an abstract might have a ripple effect further. So there's many people. I went in search of statistics blogs written by statisticians, and there is 60 best statistics blogs that you can follow. There are many statisticians. I have not found one from Africa, but there are people from who you can go and learn. So read up on those guys and girls and women and men, and learn about how other people are doing, how they are presenting their research and also the research of other people by way of example. And that's all available on the internet. I cannot vouch for the scientific basis of each of them, but many of them are very well written. And it makes it, even for me, who did not have maths at high school or to matric, it makes data and figures, it makes it more accessible. So think about how you can translate your work into a blog, for instance. Now, I want to show you an example of a research department at University of Pretoria and how they go about presenting their research to the wider world. They literally, so they have a very active Facebook page. I couldn't find them on Twitter, but they have a very active Facebook page, which means that it's free. And they have someone who literally, when someone goes to a conference, they post a photograph of the person on the conference. When someone wins a prize, they post a photograph and a short bio. One thing that they do very well is when someone has a research paper out, they do a very short summary about it in a few easy 2-3 sentences, and they have the link to the paper itself. So if you are interested in the paper, so they don't do a whole long thing, but it's basically a summary of the abstract, maybe even a little bit more easy, more simplified. 2 or 3 sentences, they post it, and they post the link. I would, in this instance, I would, if the people involved also have Facebook profiles, I would, if there's one point of criticism that I have, I would also link the researchers involved. But they haven't done it in this case. But they do that. I think there's another paper, 2-3 sentences, and it's also not always. They aren't always the main authors. Sometimes you are the contributing author. Like in this case with Sue Nicholson, she was only a contributing author. The research was done. The main authors are from other institutions, but they still own bragging rights with that. Because you are collaborative, you are still hold bragging rights. So never underestimate the fact that you're a 7th author or the 29th. You are on that paper, you did contribute. So you do have bragging rights. It's also important just to state that you are contributed to that or a collaborator on that. Sometimes also people will write, institutions will write press releases based on specific research papers. It's very important as far as you can to ask that you also add a quote or two, one sentence to that paper. And tell them, so you have now 3 voices from Europe, 1 from America in this paper, where's your voice from Africa? And be solid about that. That people, I'm from Africa, I'm an African. You need to make your voices sound louder. And other institutions elsewhere in the world need to be more representative. So if you've collaborated on a paper, you've contributed, then you are owed not owed, but you may ask for a voice in a press release. So I'm just running you through what they've done so that when they have schools visiting, they post a little bit about the schools visiting. These are all free. One thing I really like is when they have when they have new graduates, they ask the person, what's their thesis, what's it about, what's the project about, what's your main findings, short summaries. And that's the type of thing that you can post on your Facebook page of each and every researcher in your group. It's not very difficult to do, and they have a photograph of each person. I really like the way that they handle this, because it's not always that you are at this moment publishing new research, but you are working on research. So you could slightly rephrase those sentences, but in that way, you own your profile and you start building your research profile. And Facebook, and the same can be done on Twitter also. I went in search of training opportunities for science communication, training opportunities for statisticians. I must admit, there isn't much. You probably have gone through that same exercise before. But if you are going to have a paper, it's well worth reading this paper that I got about if you have a paper and you want to get some press on that, even if it's only on social media, you do need a strategy. You do need to think slightly about it. Where will you be posting it? Where is it needed? And it's also important to think about these things before your paper is already published, so that you can be ready with your yeah, be ready by the time your paper is published, so that you've done your background work, and the moment it's published, you can publish all your extras. Yeah, this is another paper that I got about communication skills and how important that is to statisticians. And then during COVID times, this gentleman wrote a paper. I found him slightly weary. Yeah, he was slightly skeptical about the media, but he has a wealth of tips there. Yeah, I wouldn't follow all of them. Then if you want to do courses, at Stellenbosch University, there's a science communication course for about 8 weeks that you can follow. That costs about 10,000 Rand. I'm not quite sure how it converts to you. But it's an accredited course and it's online. And a friend of mine, Marina Ubea, presents it, and she really has good results from that. Then I'm running out of time, so I'm going to run through this. This guy I found on YouTube and various other sources. You probably know his name. He's new to me, but he seems to be quite an influencer in the science communication statistics field. And there's a YouTube link to one of his projects and how he's communicating statistics with the media. Then when it comes to free courses, SciDevNet has training that they offer scientists in general, not specifically for statisticians, but it's also about how to integrate your gender into your research, practical guides, and it's well worth following. You can do it on your own time, and it's Africa-centered, and it's free, which is something I always like. Now, the same group that does the training in Stellenbosch, they also have a very active Science Communication Africa Facebook page. Please join. There's valuable tips, training opportunities, and talks that they host. And then there's also the SciCommer. She always sends out a newsletter with many opportunities, and some are free, some are paid for. Some are webinars, but it's well worth. If that's a field that you want to go into, train yourself how to be a better communicator of your work. One of the free resources that you can consider is the Conversation Africa. You may only publish there if you are a master's or a PhD student. So if you don't have that, or you have that degree, if you don't have that, you can't publish. It's people who bring their research, and it's written in a way that the public can understand it. They help you through the process, which is lovely, and it links. If you have a new paper out, it's well worth writing a story about what's your story. For instance, the previous speaker would be able to do a wonderful story about divorce rates in your country and how it's influenced, and why you say it's low, and why do you say it's low, but it's still high for your country, and adding that cultural dimensions to it. It would be a wonderful story, I think. And the beauty of that is you craft the story, and then it's published on their websites. It's open access. It's often picked up by other publications. So you write the story once, but then other publications pick up on it. They can use it for free, but they cannot change the story. They can use it for free, and in that way, your story is amplified by you only once writing a story. And I find that quite nice. It's a very good algorithm that they have going, and the viewership is very high, and it's well worth doing it. And so have a look at the Conversation Africa's website. Then also always make use of your in-house publications, your university, your faculty, even in your associations. If your association puts out a call for stories for their newsletter, use the opportunities, write your stories. Do not stand back. Take the opportunity and have your messages. Do science cafes, be an expert, be enthusiastic. And one last message, that train yourself how to speak about risk, because I think that's something that you often are asked about by the media and by journalists. And that's, yeah, if you are able to communicate risk well, you will also be to the benefit of your occupation. Okay, that's it. Sure.
Okay. Thank you. Any questions?
Yeah, really. Thank you so much, Angela, for this wonderful. I've always loved using a lot of mathematics. Recently, I started really thinking about science because, especially voices from Africa, for us to be heard, we need to explore other opportunities of making our voices heard. Other opportunities that people can hear us, especially the public, the general public who may not even be interested in the mathematics. And that is why I really wanted all science to do this program. You asked the question of where is your like most of these voices we've been hearing where I attended a program in Germany. Second week I was in Germany, and two top researchers in my field, that's one of the top most researchers, were going for hiking. And they were talking to themselves behind, but I was just like dropping. And one of the main things they were talking about social media presence. That they were saying that really as because it was a finance and insurance program, and they were saying really as risk managers or risk analysts. We love the mathematics and rules, but we hardly, we as mathematicians, we hardly want to deal with the social media view. That's a, they were speaking to themselves, they said this is a great missing link between us and the general public. And even funders are so interested now in how much we can be in the presence in the public public presence, our publicity.
Absolutely.
And that's one very interesting aspect that I love the fact that you put a lot of opportunities where we can really speak about our. I've never really thought about explaining myself in one sentence. I would say I'm a risk analyst. That's what I would say. But that really may not really catch that slogan may not catch up with the public. So now it has made me to begin to rethink of how to remove my identity to be able to communicate better with those who are not really mathematicians. We always communicate with the mathematicians and statisticians, but beyond that, our voices to be heard, it's important. Thank you so much.
Thank you for the opportunity. Sorry, I struggled a little bit, Quincy, to hear you. I'm not sure if you want a response from me.
I wanted to ask you a question. Hello?
Hi.
Yeah, this is I want to ask you a question. Can you hear me?
I can, yes.
Okay, my question has to do with like when you are like kind of marketing yourself. When you try to give so many ways somebody can say that I'm a statistician without putting that word statistics. So I'm just like, how can someone come up with something like that? For example, I'm a biomathematician. How can I say maybe like how can someone have a little idea? Is it by the approaches or method you use, or by kind of concepts you use in your research that you come up with those attributes to who you are? You understand what I'm trying to say? Because when I look at the example you never mention statistics in their outline. because it tried to remove the word statistic from the what you are. So I just like, what idea can you give? Like, oh, if you want to define yourself, are you going to define yourself based in your method? Are you going to define yourself based in the public? I don't know. I'm just trying to, I don't know. I'm just trying, because is it like me? I'm not a social media person. And I know, so I actually have not marketed, because there's a time I gave a presentation. Somebody called me back. I went back to check, the social media based on who you are. I cannot see anything. And you actually gave a very good presentation. Why are you not out there? So sometimes I say, oh, I will do this, but I find
it is a very
difficult.
good question. Why aren't you out there? If you are saying that no one's noticing you, what have you done to be noticed? So there's many. Be on Facebook. Have a specific page just for yourself as a researcher. You don't have to mix your social life and your research. You can have two different profiles. But have a presence. You are actually, social media gives you the opportunity to be in control of what you want to be out there. You don't have to have a website. You don't. Websites are costly affairs, but Facebook actually makes it easy for you to have your own lab. Have your lab on a Facebook. Make sure that you have your group, your research group on Facebook, for instance, or whatever the tool is or on Twitter or whatever. I don't want to. The next speaker, I'm quite sure is. I'm not sure how the time is. I'm weary about the next.
Okay, can I have your contact if I can reach out to you?
Yeah.
Anytime, so that if I have any challenge in how to go about it, I can easily get to you.
Yeah.
So I don't know if you can put up your contacts in the chat.
I will put it in the chat. So I write for Research Africa, né? So I write about researchers and their publications. So feel free to send me, if you are going to publish new work, feel free to send it to me, preferably in advance. I'd never break an embargo, don't worry. I'm going to use it. And ask me, do you think there's a story in this? Yes or no? And then you never know, sometimes there are stories in there. And then I can maybe write a story. I would love to write more in-depth stuff about the research that we do. And on your question about how to be a how to say if you're a biomathematician, how do you sell yourself? You could say that I have a very good head for figures and maths, and I use it to calculate, to help people understand and calculate how to better, say if you're working in the field of malaria, how to you help people to decide where to have malaria projects going or stuff like that. So use the field that you are working in as the hook often. So often that's the hook that will get people into the field. That's the where are you making the difference, right? So use that. And be loose about. You can use the word statistics, but tell them you use data, you use information. You can go through thousands of reams of Excel spreadsheets, and you can make sense of that, and then you use that to help people. But this is a workshop in its own. I don't want to take up the next speakers. Maybe if you do a next course, another such workshop for 3 days or something, one can set out 2 or 3 hours. I'm quite willing, and then one can go through the exercise of thinking and shaping messages, because if you start shaping your messages, that's how things start developing. You need to sometimes think about.
Okay, I think Edmore has a question. Edmore.
Thank you, Sarah Liz. Greetings to everybody there.
Greetings, yeah.
Yeah. You see, I think when you want people to be attracted to you, sometimes, you have to say what you are not really,
Absolutely, yeah. No, you are right. You are absolutely right. Absolutely.
Yes.
I tell people I'm not a political journalist. I'm not a sports writer. I'm a
because
science writer.
yeah, because recently we've seen a change of departments, the Department of Statistics, in terms of naming to say data analytics or data science and machine learning,
Yeah.
things like that. But you see, this data science or data analytics is done by people who have done, for example, some would have done an engineering degree, a computer science degree. They've done one course of calculus, an introduction course of calculus, an introduction course of statistics, and they are just good at coding and data visualization. And however, a statistician, I mean, does know the underlying data generating system, of what he's doing, But maybe if you want to get noticed or get employment as a statistician, maybe a data scientist is much better. But those people, they know very little, because much of data science is actually 90% statistics. Thank you.
Thank you, Edmar.
All right. Elimination is sometimes also a way of explaining.
All right. I think we'll take a break now. We will start again at 2:30 UK time. Okay. So it's 2:30 UK time. We will start. The next talk will be at that time.
Okay. I'm going to sign off. I'm a mother, so I have to start driving my children around now, and my own mother. Thank you for the opportunity to be here and to have been part of this. And yeah, let's continue the conversation.
All right. Take care. Bye.
Bye.
Well, sorry, Prof.
Yes.
I just to add an information, because some people were asking about email of the presenters. For the information of all members, we have a schedule on the website where all the presenters' email address and title are there. So if you need email of any of the presenter, you can go to the website. All the information are available there, so you can make further collaborations. Thank you very much.
Yes. You're right. The emails are in this link. So if you go to this link, you can see the emails of all the talks. Okay. So see you at 2:30.
Thank you.
Bye.
Bye-bye. Thank you.
Sorry, someone is asking about what interval of time. I think that will be in 45 minute time from now.
Correct, approximately.
Yeah, approximately 45 minute time.
Yeah, approximately 45 minutes from now.
Yes, thank you.
Hello, guys. Welcome back.
Hello.
Hello.
Thank you.
Hmm? To me?
Hello, do you hear
Yes.
me? Hi, do you hear me?
Yes, I can hear you, Antoida.
Anotida, Anotida, yes.
Antoida, yeah.
Yes, yes. Great.
Good
Tell
to,
me.
so let me introduce yourself from what I know. I think you did your basic degree in Zimbabwe, right? And I also did my degree at UZ. And
Right.
you went to
Only part of it. Yeah, part of it.
part
Okay.
of it, yeah.
Yeah.
And you went to Oxford to do your PhD, and thereafter you held many positions, including a chair at the University of Sussex. Currently, you're a chair in the University of British Columbia, in the math department.
That's correct.
So great to see you. So how do you find British Columbia?
It's very nice. It's yeah, different from the UK. But yeah, very Vancouver is a beautiful city. So yeah, the department is very good, and yeah, it's very nice. Things are okay. Yeah, going well.
Right.
Yeah.
Yeah.
Yeah, I also did mine at the University of Zimbabwe. And one of my lecturers was Saralis.
I see.
Yes.
I see.
But he was then a visiting lecturer, then coming from Newcastle at the time. I can't remember. He was from the UK.
Yeah.
I see.
Yeah.
Yeah.
That's very good. That's I just wanted to check if I can share.
Yes, you should be able to share.
Do you see my my talk?
Yes.
Very good. So Edmo, where are you?
I'm in Johannesburg at the University of South Africa.
I see. Very good.
Yeah.
Right. Is that in Johannesburg?
Johannesburg, yes, but yes. But the main campus is in Pretoria, but the College of Science.
I see. I see. I might have passed through there. I just went to University of Pretoria last year, so I was on the way.
Okay, yes.
Yeah,
the
it was
building
my first time in Pretoria. So yeah.
Oh, really?
Yeah.
Okay.
Yeah.
You know Samuel Banda?
Yes.
I
know.
Yeah,
he's the chair now.
Head of the statistics department. He and I, we studied together at Sheffield. Yeah. Yeah.
Okay. I've known him for a while, even when he was at MRC.
Oh. Okay.
Yeah, let me know when you're ready. Then I can.
Okay. You can start. You can start right now.
Yeah.
Yeah.
Okay. Yeah. Welcome. It's my pleasure to be here. I just want to thank Saralis and Queensley for the invitation. I'm not so sure who is hosting this. Is it the ICMS who is hosting this workshop?
No. It's just the two of us.
I see.
Yeah.
I see. So
Yeah.
very nice, very nice. So yeah, it's a great pleasure to talk to you. I'm not a statistician, but I work on PDs and stochastic PDs as well. I'll demonstrate that some of those as an example. I've been asked to talk about the UK APASE program, and I'll talk about it later on. But since, I don't know the community, this particular community, but I know some people, Farai Mhlanga is here, I think, Queensley and so on. I've given talks in the past, so they might have seen some of this work. But I just wanted to sort of give you a notion of what my research is. I'll keep track of the time here. I've only half an hour. So my research is really to develop models for single and collective cell migration. I did my PhD on pattern formation and in developmental biology, applying models to pattern formation. But I realized very early on, that experiments were very difficult to get for pattern formation. And so it was just by chance that I came across papers on cell migration, and it turns out actually that the models that you use for pattern formation are really readily applicable to cell biology. So that's really what my research program is. It's data-driven approach for developing mathematical and computational models for cell motility and pattern formation. And I use what I call back surface PDs, but these are also stochastic PDs as well. So I look at a single cell, for example, depicted here in yellow, and it's evolving, it's moving, its boundary, its gamma of T, it's enclosed by this cell membrane. You can think of it in that case. It's well connected, unless of course the cell is dividing. So we assume in many cases that it's not, but I mean, we have other models that we have developed for cell division using phase fields, for example. So for this talk, I'm just going to assume that the cell is well connected and so on. The environment is a complex environment. I've been very crude here to denote it by omega E. It's also time dependent, but it's also because it's being deformed by the cell. And so what's my goal? My goal is to formulate these models that couple mechanics and biochemistry to understand single cells, how they migrate through these complex environments, how they can identify their front and back, because unlike us humans, we know what is our front, what is our back, but cells have no idea. So they have to have mechanisms of trying to, sort of guide them as to what is their front, what is their back. And I'll show you just an example of this. So it's the mechanics, and these are continuum mechanics models. I give some examples here. It depends really on the geometry. If you're looking at the cytoplasm or the nucleus and so on, or just the surface, you can think of it as hyperelastic surfaces or morphoelastic surfaces. And so you use force balance to formulate these models. Also for the biochemistry, these are just reaction diffusion systems, really, for polarization. When I say polarization, it's when the cell can polarize to identify what is its front and what is its back. Another big part of my research program is not only formulating these models, analyzing them, doing asymptotic analysis for where you can, but in many cases we cannot analyze them, get analytical solutions, and therefore I dedicate part of my work to developing numerical methods for these models. So numerical analysis is important. High performance computing is also important, because we want to fit these models to data, and that's the next item, number 3. I also need fitting models to data and parameter identification. You are already going into stochastic PDs. sort of Bayesian methods for fitting PDEs to data or ODEs to data. So that's also part of my research. Just to give you a taster of what are single cells, I hope you can see these movies. So I have a single cell on the left and on the right. This cell is migrating with very little changes in topology. You can see traveling waves as the cell is migrating on the substrate. This is a projection from the top. It's migrating randomly, but in a sort of a directed. You can see it is direction. Yeah. While this cell on the other side, it's really having substantial not changes, but in topology. Yeah, it's not changes in terms of cell division, but you can see it's forming these pseudopods, sensing the environment, forming these pseudopods which sort of lead it to migrate in one way or the other. How it decides to retract and move in the other direction, it's again something that we're interested in modeling. So that's one example. The other example, which leads us naturally to bulk surface PDs, is this cell here. Again, it's you can see the colors. I hope the colors are clear. You can see the green at the green end. This is acting at the front end of the cell, and the cell is really moving preferentially in that direction. Yeah, where they are highly concentrated actin molecules. These are proteins. Yeah, these are proteins. And the cell moves. When they are uniformly distributed, the cell is almost roundish and it doesn't really move. You can see it's almost round. And then suddenly there are highly concentrations of actin. It moves. At the back end, you have myosin, which helps the cell to retract in order to move forward. And so they are concentrated mainly on the surface. So you can think of these as surface PDs, for example, if you want to model this. But if you look inside, there are also myosin and actin, not highly concentrated in the middle. So there are some molecules that are also inside. And these are observed experimentally. And again, this leads naturally to what I call bulk surface PDs. What is the bulk? The bulk is the inside of the cell, and the surface is the membrane really on which one is to pose the cell, the models. Just again to give you an idea of what models I'm dealing with and where stochasticity comes in. I'm sure there are people here who are doing stochastic processes, maybe probabilities, whatever. But you can have a notion of what I'm talking about. So I'm going to assume, and this is important, I'm going to really focus only on the cell membrane, rather than looking into the bulk. We've done some modeling on the bulk. I'm just going to focus on the cell membrane. And I'm going to postulate this mechanical model. It's a geometric evolution law of the motion of the cell membrane. How does the cell membrane deform? And it's a force balance equation for the cell membrane. Yeah. And I'll give you in a minute what this model is. The evolution law of this membrane, how the membrane is deforming, is also deformed or driven by the biochemistry. So you have reaction diffusion systems or equations that drive the mechanics. And how do we do that? So I'm just going to look at the molecular species that are residing on the cell surface. So this is, again, I'm just giving you a taster really of what the models are. I'm going to assume that I have N species, B species, that are residing. These are the actin myosin that are living on the cell membrane. That's where they live, not in the bulk. So they are on this gamma T. Gamma T is an evolving cell membrane surface. Yeah, it's a curve in 1D, it's a surface in 2D, in 3D, sorry. Yeah, so it's a curve in 2D, it's a surface in 3D. Yeah, and so the B species, this is the rate of change. This is the material derivative of the B. Really, it's expressed here in terms of the rate of change of these molecular species in time, plus the dilution term, again proportional to the velocity, and you have here the convective term here. So if gamma of T is incompressible, the divergence of this velocity is 0. I'm talking of surface gradients here. So if you look at the second term after the equal sign, so this is diffusion. It's a random process, and we represent it as diffusion. you end up, if you compute this nicely, you end up with the Laplace-Beltrami operator rather than just a classical Laplace operator. dB is a diffusion metric. It could be time dependent. It's normally it's time independent. So it could be space dependent, or it could also depend on the B molecular species. On the last term are the reactions. So where the B is this B1 up to Bn, they interact. Yeah, they talk to each other on the cell membrane, and they again these interactions, these reactions we derive them from experiments. And that's where also the stochasticity comes in. Yeah, S represents here the stochasticity. And in particular, it could have two components. The chemotactic, if it is sensing some signals, you can have one term, so for directed cell migration. But if it is just a random, then due to noise in the environment, then it's just random cell migration, really. So these two components, and you can, for example, use the Ornstein-Uhlenbeck stochastic process to represent the eta, for example. Yeah, where you have the Wiener process. And we solve this using the Marijuana method under the finite element method. Yeah. I'm not going to go into the details of how I do this. If anyone is interested, I can go through the details. Also, I can give you some references. So now the question is, I've given you what are the representation of the behavior, the spatio-temporal behavior of actin and myosin. And the question now is, what is this material velocity V? And that's the next thing that you have to model. You have modeled the molecular species. How do we model the material velocity? I'm just going to take the material velocity in the normal direction. And it's a force balance equation. I've written, don't worry about all this, but all I'm saying is the material velocity is driven by the forces acting at each material point on the surface. And this could be protrusion forces, resistance forces, or bending energy. The membrane has energy in it. And so you can model that. You have also volume constraint or volume conservation, depending on the nature of the cells that you are looking at, whether they conserve their volume or volume changes, but it does not change substantially. That it oscillates between a certain volume, for example. You can also have interior forces that you have. And this is just an example. I think forces here generated by, if you look at this, they are generated by the molecular species. The second is just what I've described as resistance force, and it's given in terms of the mean curvature, H, which I described here. And this is the Wilmore flow that describes energetic membranes in differential geometry. Yeah, and this leads us naturally. If H is the main curvature, it's a Laplace-Beltrami operator of your special components. If you take the Laplace-Beltrami operator of H, you have a fourth order PDE on the surface. It's highly nonlinear because you have the Laplace-Beltrami operator to the power 3. If you look at it, and so these are not trivial PDEs. These are PDEs on manifolds that are quite difficult to analyze. In many cases, people do in analysis of PDEs. They look at steady states. For the manifold. Here we are looking at dynamics of manifolds that are never in equilibrium. They are far from equilibrium. So that's also very important. Just to give you a notion, I realize I'm running out of time already. Just to give you a notion, so we can solve this in 3D, but I'm going to give you results in 2D. You can have random migration of single cells, or you can have directed migration. Let's just give you an example, a tester. And this is a neutrophil cell that's chasing bacteria. You have been all to lunch, and probably you had to walk to somewhere to get your lunch. And this bacteria is chasing, this neutrophil is chasing bacteria to eat in the presence of deformable obstacles. So it has to fight to get to its food. And that's, again, experimentally observed famous movie from the 1950s even. So what does it tell us? Can we do this computationally? Again, this is proof of concept. You have a computational cell based on those models that I showed you that is behaving very similar to what is observed experimentally in the presence again of deformable objects. Yeah, and so this is very nice that we can capture the basics of this experimental the physics of the single cell in the presence of deformable objects. Just again to give you another example of directed cell migration as a collective cell migration. Again, in the presence of a contracted signal, you can have the cells migrating towards the source of the signal. And so they can sense this is mainly directed, although this is lost somehow, but at the end of the day, it's attracted to the source. Yeah. So finally, can we make these two experiments? And these are experimental observations of cells which sort of cluster in some sense. So clustering of cells is important in biology for the formation of cancer and all other bad medical sort of conditions arising from cell motility. So this was just again an example of my research. Part of my research, it's one component of my research. I'm interested in single cell migration in terms of stochastic PDs. So what is the UKRPASI? I go back to the title. So when I proposed this program in 2018, I applied to the UKRI. The idea was to support sort of developing collaborations between UK, Africa, and also other sort of academics from North America, mainland Europe, and so on. So, in order to build to advance the mathematical sciences really in Africa in some sense, yeah. So the UK APASI means Africa Postgraduate Advanced Study Institute, yeah. And this was established in 2019. The starting date on the grant was the 1st of April 2020. We all know what happened during that year. I don't think we can ever forget. So this was supposed to start, and as you will see in a minute, we had plans to travel to Africa and so on, but everything went out through the window because of COVID. And so the EPSRC gave us £157,000, of which, because of COVID, we had to return 70,000 at the end of 2 years because we could not use it. Everything was done remotely. And so, again, this was, when you talk about sustainability, I wish, the UKRI or EPSRC could have said, okay, you can continue to use this money for the future, but they decided to take it back. So in terms of the investigators, I just give you a notion here of who the main leading investigators were. And Edward Lungu, you might know him from Botswana here. Farai Nyabaza is the former president of SAMSA and is the head of department at University of Johannesburg. You might know some of these gifts in Chatipa, I think, and so on. So yeah, we had a mix of people from Africa leading the program, as well as from the UK and so on. Yeah. So that was that. What was the objective? And this is the funders' objective, was building capacity to tackle global development. So this was under the GCRF or something like that. The UK called it Global Challenges Research Fund or something like that. Yeah. So to tackle global development challenges in Africa through mathematical sciences. Yeah. And I think this is something that's becoming prominent now, that funders are investing substantially in research in Africa. I'll show you again some examples in a minute. And so, yeah, again, what was the main objectives? To strengthen UK and sub-Saharan Africa for human infrastructure development, to forge and sustain collaborative relationships between applied mathematicians, to use mathematics to influence government policies on disease, crime, and wildlife management, control, and prevention. What I will say is, from my experience since then, it's very difficult to engage governments. That's one problem I will highlight. Also, it's not so easy to translate mathematics into policies, and that's something that we have to work harder to get to. But it's really important that we satisfy the funders in their quest to influence decision making. Yeah. And also to contribute to this, the mission of, I call this the Southern Africa Mathematical Sciences Association, which I'm associated with, and the Massamo program, which we initiated in 2010 in order to train, again, mathematicians within Africa without moving them out of Africa. And again, that was also part of this UK APASI, that we don't have to relocate to other countries, as I did, in the late 90s. Yeah, there are lots of people who need opportunities. Just to, again, to give you an example of our first inaugural workshop, everything was hosted by the ICMS. That's why I was asking, is this meeting hosted by the International Center for Mathematical Sciences in Edinburgh? And our first speaker was actually Philip Maini as a plenary speaker. So you can identify, some of you can see yourselves. There's Sandile Motsa here. I could see Farai somewhere, but now I cannot see him. There's Farai Mhlanga, there's Gift here. There's Fred Vermeulen, my friend from Belgium. He was at Delft. Again, he has been substantially involved. There's Stephanie Pottet, some of you might know, from Manitoba. There's Julian Aaron here. There's Dumitru. So there are lots of academics who are really interested in aiding, helping advanced mathematical sciences in Africa. Yeah, AJ Mayer as well, who is in the US. I mean, it's really the right time to be involved in the mathematical sciences in Africa. As a result of COVID, all our workshops were hosted by ICMS, and we had about 10 of them, 10 workshops from 2020 to 2022. And they're given here. You can find the link, or I can send you the link if you wish. In the interest of time, I'll just move on, because I think it's important to recognize the people who contributed to the UK APASI in terms of the plenary speakers. Le Keshet is a colleague of mine here at UBC, so I invited her to give a talk then. I didn't know during that time that I was going to be at UBC at all. It was just, yeah, I don't know, it just came out of the blue. Anyway, it's for another day to discuss. Philip Maini, Keys was at University of Sussex. Also, I could not find the address for this guy because he's Italian, but he lives in France and is not associated with any university. Alberto was terrific for PDE. So again, he just volunteered to give talks, semi-retired, you can say. And so this was very nice. But also the people who gave lectures, they gave in-depth lectures. Paul was the scientific director for ICMS, so he opened the workshop. What else? I should acknowledge Dawn and Liam. They did a fantastic job in supporting us through those 2 years when we were hosting workshops. Sadly, they've left the ICMS for greener pastures. So what are the outcomes of the UK APASI? It is established, in my opinion, multilateral collaborations. Queensley is here. She's also advocating for that. She was a participant, and I'm really glad to see her sort of taking the flag and running with it, as we say. And so it's very nice. It has also created research teams in epidemiology, finance, and cell dynamics. In terms of capacity building and training of early career and mid-career researchers in Africa. I should have, this is only for the UK APASI. We trained around 35 fellows. But in my experience from 2010, when we had this Massamo program, we trained around 25 to about 50 fellows every year through the Massamo program. So, I mean, we have been involved in Africa for more than a decade in terms of mathematical sciences. So I'm happy to see it again continuing. Yeah. What else shall I say, really? This is important. I don't know how many of you know, but the Wellcome Trust and the Bill Melinda Gates Foundation, the Simons Foundation, the USAID are plowing lots of money into epidemiology, into infectious diseases, into public policy. And I encourage statisticians in particular to be involved, because they are probabilistic, in fact. The challenge is how do we translate, how do we fit our models to data, how do we model public policy, how all these are, there is some randomness involved, and so stochasticity is very important, and it will be good for you to be involved. And so on. Yeah. I should also just give you a taste of the challenges that we face and the possible solutions. These are just out of my what I feel should be addressed really. The first thing is to identify research questions and the research network. Yeah, and these, in my opinion, these research questions should be driven by the users and the practitioners. Yeah, the policy policy makers. I should have said here, policymakers, practitioners, NGOs, and governments. They should drive the research questions. We should base our modeling on real observations. Like I showed you for experiments, you have those experimental observations, then you derive the models. It's the same thing for epidemiology, it's the same thing for public policy. They have to be driven by the users. And that's what I'm proposing here. So you seek partners across, this is important. You have to seek partners across several and sometimes non-traditional disciplines. So interdisciplinarity is important, multidisciplinarity is important, building new bridges is also important. Just be open-minded. You cannot do this in your office, you have to leave your office and leave also that notion that mathematics is just simply pure mathematics. Pure mathematics can exhibit its beauty in applications. And I think that should be recognized. And I think that's, it's important. Research consortium agreement, these are difficult when you are working on this type of partnerships. So you better start early and find the right legal advice and support. Yeah. For memorandum of understanding, yes.
I think the time that I think you have, the time is
1
up.
minute.
Okay.
Yes. Okay. Just also staff recruitment, internet. There's load shedding everywhere in Africa. You have to be prepared for these things. Banking and exchange rates in Africa are also volatile. That's why we model them as stochastic processes. And therefore, I give here, maybe this should be the last page, I guess, in terms of what is out there at the moment, the funding that's out there, the Wellcome Trust, the Royal Society, very few people in mathematics apply for these future leaders. It used to be a program that I was on a panel as a reviewer, one of these people who selected these fellows, and there were very few mathematicians applying for these. So I will stop here probably because I can take questions. And before I do so, I just want to thank my funding bodies who have supported me. So this talk in particular came from this where is this grant here? Yeah, the UK APACI grant, EPSRC. Yeah, so I stop and I take questions. Yeah.
Thank you. We wrote to ICMC, but they did not reply to us. It seems that they didn't want to fund us or something. And with respect to all the workshops you have done, I like to know, like, are people following up on the progress of researchers in Africa, or is it just a one-time thing?
We do. So the idea is to cultivate that culture of having weekly meetings, regular meetings, research meetings through, so we do. There is follow-up. In fact, that's why the SAMHSA conference comes into people later on present their results at the SAMHSA conference or other conferences in Africa or international conferences. So we follow up. This is not, it's a continuous, you try to have a continuous sort of involvement of the research teams. Yes.
Okay.
It's quite easy now with WhatsApp, with you can also create links for them, Zoom links, and share with them, and then they can.
I'm sure you do follow up, but my question refers to the European partners or the American partners. Do they actually follow up?
Absolutely. I host regularly. I have regular meetings with my research teams from North America to Europe. As I said, Fred Vermeulen is one of them, and so yeah. It's just finding the right times to do this. But yeah.
Okay, good.
Yeah. They are very keen on this. I mean, we benefit, you benefit. We have publications. We influence policy and so on. So yeah.
Exactly,
it's a win-win for everyone.
Yeah. I mean, I find it very difficult to get any funds, but yet I'm working with many researchers in Africa in statistics.
Yeah, but I think, yeah, if you talk to me, I can link you up with the fund we are applying. I just applied last week. The deadline was last Monday. I applied 3 grants to the Wellcome Trust, £3 million for these grants each of. I mean, I'm not going to win all of them. Probably none of them, but you have to try. So yeah. There are lots of opportunities. There is one now. There is one grant that's out. USAID has released 45 million for epidemiology in Africa. And that's a lot of money. Yeah.
Okay.
Yeah.
Thank you again for your talk. I mean, it's really inspiring.
Thank you.
Thank you.
Thank you.
Right. The next presentation is by our own Kingsley. So, I mean, she has become one of my best friends right now. I mean, Kingsley and I have been communicating almost weekly for years. So I will let her take the floor.
All right, thank you so much. Share my screen. Let me thank Anutide for a beautiful presentation and the information given. He has really been one of my mentors who has inspired me and has given me renewed energy to continue in spite of the challenges. I'll be talking on a network flow approach to understanding climate finance distribution across sub-Saharan Africa. So I'll talk about the motivation and problem solving, and this is the outline generally. And since it's not the strict traditional type of program, I would also talk about one of the issues or aims of this program is to actually voice out our challenges as researchers in Africa living on the continent. Actually the problem is that the structure, the network structure of climate finance flows is quite complex in nature. So we have, especially, I'm referring to the global public finance from multilateral sources. So we have the donors from majorly the global north who send funds to the global south. And sub-Saharan Africa is arguably one of the hardest hit by climate change, even though they contribute the least to the problem. So this actually affects the governance system on the continent with respect to climate finance. And that's why most times Africa is lacking at the negotiating table. So all the policies are made on their behalf and applied on their behalf without them really having a say. So really understanding how this flow works is critical, especially at this point in time. So that's what this study is all about, to actually analyze the network system of donors and recipients using network theory. So this is a new area, maybe like possibly it's not up to 10 years. And the quantitative analysis on distribution of climate funds is even maybe not even up to 5 years. So we have like Salvador et al. In 2021 that actually started looking at quantitative mappings of adaptation finance. And Doku and other authors actually use regression techniques to actually find out which countries in Africa are more likely to attract climate finance. And I and Sarah Lisa have also worked on to look at the frequency and severity, to look at distribution models that can be used to, a distribution that can be used to model the frequency and severity of the flow of these funds. So the data itself is a sample size of 667, and there were 48 African countries. So the data source is actually Climate Fund update website. So from there, I just extracted for the African countries as for Sub-Saharan Africa, and the time period ranges from 2003 to 2020. So there were 20 multilateral funds. I only picked on multilateral funds. Multilateral funds implies donors from different countries coming together to collect their funds and send. So we have among this from those from Germany, America, I think UK is one of them. So the modeling process, actually, I'm looking at both the static structure and the dynamic structure of this flow. And for the modeling process, I had to follow a particular pattern. I decided to use a numeric code to identify both the multilateral funds and the African countries. Then the nodes, we have the tail node and the head node. So the nodes represent the donors and the recipients. So the head node represents the donors and the tail node represents the recipients. And then the edges represent the flow. So the flow of these funds from which multilateral fund to which country. So that's the main assumption is that there are no self-existing or no self-edges existing. There's no country is funding itself. In reality, actually, there are national funds for climate, but I'm looking at international transfers. So in that sense, I'm assuming that no African country is funding itself when it comes to the specific data being used. So using the network structure, I was able to obtain the structure of the climate funds. The light blue represents the donors and the maroon represents the recipient countries. Looking at this structure, there were some specific observations that I noted. The first is that the network shows that the multilateral funding units fall into two major categories. We have the central funding unit and the boundary funding unit. And I identified an isolated region at the bottom here. You see there's no single funding unit, no single boundary funding unit. Now this central funding unit funds many countries at once, while the boundary funding units fund only very few countries at once. But in this isolated region, they are only fed by the central funding unit and they don't have a boundary funding unit. And most of these countries are from West Africa. Example, Benin, Burkina Faso, Gambia, Senegal, and then we have some other regions like Ethiopia and Sudan. But South Africa is one of the, takes the largest share of the climate finance because it also emits the largest greenhouse gas. So, well, let me just continue. So I have to incorporate the dynamic nature of the network. I had to use time points to understand the temporal evolution of the flow. So we have the onset and the terminus. The onset is the time the actor came into the climate finance network. That's when the project was first approved, and the terminus is the very last year the last project was approved in a given African country. So for example, we have the GEF, which is actually the means green environmental facility. So the approved funds in the year 2006 to 2010. So 2006 represents the onset, and then 2010 represents the terminus, and the duration is 4 years. So duration is like an attribute of the model of the network. With respect to like Angola, it's different projects were approved from different funding units, but the starting year was from the data, was from the year 2008. So that represents the onset and the last project that was approved was 2018, which represents the terminal. So the duration is like 10 years. So given that there were no completion dates of these specific projects that were approved, many entries were missing in the data. So I used a standardized time period. I set a standardized time period for 3 years, 5 years, and 10 years. So a project, if the project is a short-term project, it will take 3 years. If it's a medium-term, 5 years, and if it's a long-term, 10 years. And so using that, I plotted the network, breaking it into successful temporal slices to see how the evolution takes place. And this is like how the evolution takes place here. So we see the 5 year, the first one is 5 year, 3 year, then the 5 year, then the bottom one is a 10-year project. The project that takes up to 10 years to complete. And some notable observations were made. The first one is that longer term projects tend to mature or transform faster than 5 year or 3 year duration projects. And then there's a persistent pattern of sparse neighborhood emerging around the year 2010 for 3 and 5 year projects. And so having done this, I try to understand how does this affect, or what's the implication for practitioners. As Professor Anoti said, the practitioner should be the one to actually bring the problem. I mean, the problem should be be something that really disturbs the practitioner. So first, the less dense region, the isolated region, kind of reveals some sort of vulnerability position for those countries that are located in that space, where they only have one source of funding, which is the boundary funding unit. And so in times of financial crisis, you have a problem where maybe the boundary, the central cannot really accommodate, and so those countries even suffer more from lack of funding. And climate finance is actually critical to accomplishing the climate goal set. Then this also brings to fore the issue of equitable resource allocation of climate funds. Now for the dynamic structure, where I noticed that longer term projects mature faster, it tends to suggest, and this is my opinion anyway, it seems to suggest that projects with longer term have a higher probability of being fully funded, because maybe a lot of planning is involved in such projects, and so donors tend to see a more clear picture of what the project's all about, what the steps are, the steps involved, the processes involved. So from the data, it shows that only just 63% of all the multilateral climate funding units had only disbursed only 50% of the approved funds. So the fact that it's approved does not mean it has been disbursed. So only 50% of those funds have been given out, based on about 63% of the multilateral funding. So it shows that there's a very slow pace in actually disbursing the funds that have already been approved. And it may also imply that projects with longer term tend to have tend to be funded fully than shorter term projects. So this presents opportunities for practitioners, especially for climate fund negotiators in Africa, to be able to have a much more evidence-based platform, or be more informed on how to negotiate, especially for multilateral funds that are coming into play. They could find which particular countries to actually fund at the boundaries. So that being said, as a researcher on the continent, I personally have never really felt the need to move out of my country, out of my continent. That's like if to go and live, to go and reside fully in another country. I believe I have work to do from within. And so the challenges I have faced personally as an African woman in STEM, definitely women in STEM are limited globally, but as an African woman in STEM, particularly in mathematics, we have like just less than 11% of doctoral degree holders who are women in mathematics. So it's been a rough ride. As a mother, I married very early. So that's some of the challenges we face. I married before I went into the university, and suddenly within 7 years, I found out that I had 4 children, and 6 years later, a 5th one joined. So combining this with workplace load, classes that have been loaded like 4, 5, 6 classes really gave a big blow on me. Finding out that maybe for 6, 7, close to 10 years, I couldn't even do a single research. But the only thing is that I held on to the currency of excellence and confidence. And funding does not come to us. We know that that's a major problem African researchers face, especially early career researchers. We are not even really, we may not even have a voice. But there is also a currency in terms of excellence and confidence. And that is not cash, but it's money. It's money in the making. And I think that's one thing that really kept me in spite of family, because there was a time there was a crisis in where I used to stay. I had to move with my 5 children to only me and my children. My husband had to remain back where the crisis was because of business. And so for like 6, 7 years, I was just carrying the load of the whole family. But this confidence kept me moving. And the love for Africa to remain on the continent actually was inspired, or should I say was increased, yeah, because I have love for my continent naturally, but was increased when I went for my PhD program. And there was a course we did, and it's called African History. And after that course, African History, I developed a new way of looking at the continent, or the new way of looking at how I can actually play a major role in bringing people up. So that's why anywhere I go, I try to emphasize cooperation over competition. There's need for, especially we on the continent, to really collaborate, and this is one of the platforms for doing that. Quite a number of projects, like I and a colleague here just finished a project we did for mentoring sub-Saharan African women in mathematics and statistics. So it's a passion for me, and I hopefully, as our voices come together, it will become louder and we can be able to be recognized globally. Thank you so much for listening.
I think you are a Wonder Woman. I think that you are one of a kind in Africa. I wish there could be more people like you in Africa. Yeah. Any questions? Kingsley talked about grants. So if any of you guys, especially Anotida, if you are applying for your next grant, please let us know. We will try to, Quinsley and I will try to contribute.
Yeah, great. That's very good. So yeah, yeah, we can discuss some of this later on, because yeah, there are opportunities. The networks that we are establishing in for the Wellcome Trust and the Bill and Melinda Gates Foundation, we are still looking for partners. So this will be some, if we are invited to the next stage, then we can explore those opportunities. Yeah.
Okay. Farai, you have a question?
Thank you. Maybe mine is not necessarily a question, but to say that maybe this platform is a. Thank you very much for this particular platform where you have brought together a number of researchers across the continent, because I think it is critical that maybe from this colleagues need to form some kind of clusters and look forward to some funding that will be available, and people can actually submit application as teams or as researchers from different universities or different countries. And I think depending on the nature of the calls that people will be responding to, you may find that maybe that also gives an edge to the application. So I think this cluster, this workshop actually creates that opportunity for us to start working together. From different countries, from different universities. Then when there are these kind of things, then we can respond them together. Thank you.
Sure, thank you. There's another person raising the hand. Can you discuss your comment?
Hello, good afternoon, everyone.
Yes.
I would like to appreciate the organizers of this program. And my question is, are there grants that are area specific? And secondly, I also want to comment on based on what the last speaker just said on the issue of forming a cluster or research group. I think it's a very good idea. If we can have that, we can achieve a lot. Thank you.
Yeah, I for one, my specialty is statistics. So anybody working in any area of statistics, I'm prepared to collaborate and help in any way I can.
You're welcome.
As I said before, I work with researchers in about 20 different African countries right now.
That's nice.
At the moment, nearly all my collaborators are in Africa. And I will continue to I will continue to work with researchers in Africa only. Although in the past I have worked with researchers from Europe, from America, from India, China, and other places. But I have decided for the future, I plan to work with researchers in Africa only. Okay.
That's interesting.
Any other questions, comments? Right, the next speaker is gonna be Akalu from Jimma University in Ethiopia. Hello.
Hello, can you hear me?
Yes, I can hear you. How are you, sir?
I'm good, and you?
I can hear you, sir. Yeah.
Okay.
Can you increase your volume, please?
Okay, can you hear me now?
No, can you increase it a little bit? I mean,
Okay.
your volume. I mean, your
Slide.
the volume of your sound.
Can you hear me now? Can you hear me? Hello.
No, can you? Yeah.
Okay.
Okay. I can hear you now. Yes.
Thank you. Good evening, everyone.
Yeah.
I am Akalu. I'm currently in Jimma University in Ethiopia. I was a PhD student at Hasselt University in Belgium. And I will now present you part of my dissertation. And it's entitled Dynamic Borrowing of Information from Multiple Historical Trials Using the Power Prior Approach. So I'll briefly introduce you what the contents and what the subject matter is and what the power prior approach itself is. And I will present you some motivating data examples. I will have some simulation study. And finally, I will conclude with some remarks and recommendation for future research. And all of my presentation will be very brief so that I just removed many technical parts. So, and our work has been conducted in the context of randomized control trials, which are regarded as a gold standard for evaluating the treatment effect. This is mainly because in RCTs, randomization guarantees unbiased estimates of the treatment effect. However, RCTs may not always be easily conducted. For example, in rare diseases, recruiting sufficient number of patients in a reasonable time frame is not likely. And also in pediatric studies, obtaining ethical approval is very difficult. Therefore, it could be useful to include historical information in the analysis of new trial. And luckily, RCTs focused on the same health outcome. Control arms often receive the same treatment. And inclusion of historical information may reduce the required number of patients in the new study. So to incorporate historical information in the analysis of a new study, the Bayesian approach is a natural choice. So based on the Bayes theorem, we can derive the posterior distribution of the parameter of interest by combining the data with prior information. But to incorporate, incorporation of historical information can be applied in two ways. That means it can be fully, for example, by pulling the historical data with the current data, or by discounting the historical information, depending on the discrepancy between the historical and the current data. And in that case, we apply dynamic borrowing methods. And our focus is here in the dynamic borrowing methods. So historical information in clinical trials can be borrowed from the historical trials. That means both from the control and experimental arms, or only from the historical control arms. And our focus was on the historical control arms. And to incorporate historical trials in the analysis of the current trial, the historical trials must be similar with the current trials. For example, in terms of the control intervention, patient eligibility, outcome measurement, study and patient characteristics, disease process, and intervention effects. Okay. So we had a motivating data set obtained from a number of randomized control trials for acute myeloid leukemia patients, and it was conducted by HOVON. This HOVON is hemato-oncology group located in Erasmus MC in Netherlands. And the end point of interest was binary. It was a complete remission from acute myeloid leukemia. And then the aim of a study, or the aim of our research, was to analyze the treatment effect in HOVON 42A trial here. The current trial, current trial was HOVON 42A trial, but we had 4 historical trials with the same control treatment. But based on the aforementioned criteria, they are called actually POCO criteria, we could select only 2 of the historical trials, the HOVON 29 and HOVON 42 trial. Now, our aim will be to incorporate or to incorporate information from this historical trial in the analysis of the current trial, which means the current data. So the main 2 existing dynamic borrowing methods are called power prior, are based on the power prior approach and the meta-analytic predictive approach. So the power prior approach has equal but discounted assumption. It means that the model parameters are the same across trials, but the historical likelihood is downweighted using a power, say, parameter called delta between 0 and 1. So 0 means ignoring the historical information, and 1 means full incorporation of the historical data. That means the delta parameter determines the amount of borrowing, and so it can be between 0 and 1, any value between 0 and 1. And the meta-analytic predictive approach has exchangeable assumption. It means that the model parameters are different across trials, but they are centered at mean parameter under normal distribution. So in this approach, the variance parameter determines the amount of borrowing. It means that when this variance parameter is large, it means less amount of borrowing from the historical trials. So these are the 2 main dynamic borrowing approaches. So our main objective in our dissertation, actually these are the 2 main objectives that I pick for this to present in this conference. The first objective is adapting the power prior approach with multiple historical trials, and to evaluate this approach in the presence of measured confounders. So the initial power prior approach was developed based on a single historical study, and with the power parameters that determine the amount of borrowing was fixed in advance. And in that case, the posterior distribution of the model parameters was evaluated or calculated given the historical and the current data, and also the power parameters that determines the amount of borrowing. However, this parameter can be estimated from the data depending on the discrepancy between the historical and the current data. And in that case, the power parameter becomes random, and therefore joint power prior is calculated. In this case, it is conditional power parameter, but in this case, it becomes joint power prior of the model parameter and the power parameter. But the immediate power prior approach does not satisfy likelihood principle. It is a Bayesian likelihood principle, which says that proportional likelihood should produce the same posterior distribution. So this joint power prior will not satisfy this likelihood principle unless it is divided by a scaling constant. Unless it is divided by a scaling constant. In that case, the joint power prior will satisfy a likelihood principle, and this joint power prior now is called modified power prior. So when multiple historical studies are available, the modified power prior can be straightforward generalization. But in this case, we assume separate powers to each historical study. And then the modified power prior will be calculated by multiplying the likelihood of each historical study to their respective power parameter. And all will be the same, except this multiplication here. And in this case, again, the modified power prior have different types. I mean, we have variations of modified power parameters, but I now, again, reduced it. The two most commonly used modified power priors in case of multiple historical studies. The first one is independent MPP, modified power prior. In this case, it assumes that the power parameters are independent. And the second is dependent modified power prior. In this case, it assumes that the power priors are dependent. Actually, this was the one that we extended in our dissertation. And the motivation behind this assumption is that since the historical studies are similar, if they're the historical studies are selected based on a strict application of comparability criteria, then they become very similar, and therefore the power parameters should be also similar, and therefore in that case it will be dependent MPP, or we call it DMPP. Okay, so the next step was to analyze our data set based on the different borrowing methods, such as the meta-analytic predictive approach, the robustified version of this approach, the MPP independent, the one that I just introduced, and the DMPP, the one that we developed in our dissertation. The current data means ignoring the historical data, and pooled data means pulling the two historical data. So based on our analysis, the most important finding was that the dependent MPP improves the precision of the estimate as compared to the analysis without historical data. But again, we performed simulation study to evaluate the performance of the dynamic borrowing methods based on type 1 error rate and calibrated, power actually, based on type 1 error rate and power. But since for some of the methods, the type 1 error can be inflated. So we again calculated a calibrated power. That means a power at exactly 5% to balance the trade-off between the type 1 error rate and the power. So the most important conclusion here is, actually here we have different scenarios. For example, we computed for no heterogeneity among studies, low heterogeneity among studies, and etc. And the most important finding in our study was that the dependent MPP offers more statistical power as compared to the analysis without historical data, but it will be at the cost of inflated type 1 error rate for high level of between-tier heterogeneity. If you see here, it gives an inflated type 1 error rate. So we again evaluated our methods for a linear regression model. That means a Gaussian outcome in the presence of covariates. So in that case, the modified power prior approach should handle some covariates beside the treatment type and multiple model parameters. And we now need to calculate the scaling constant with multiple integration, the one that we have in the denominator for the power prior approach. But the existing computational approach for the modified power parameter was based on only a univariate parameter and a joint distribution of model parameter and power. And in this case, the linear regression model will have no closed form solution based on the existing computational approach. Therefore, we developed a new procedure for computation. And so step one of our procedure computes marginal posterior of the power parameters. And in step two, we compute now posterior of the model parameters. In this case, the scaling constant that has an integration has a closed form expression. And our MCMC computation in this case will be based on Metropolis Hastings algorithm and self-written R program. Actually, all this MPP approach will not be computed based on some standard software such as Winbugs, JAX, or etc. So we need to write some R programs. So again, we performed a simulation study in the presence of covariates now, but now the source of variation will be covariate distributions, for example. And in that case, we make data generation so that the source of variation is based on covariate distribution, and we analyze the data including the covariates and excluding the covariates. When the covariates are excluded in the analysis, all borrowing methods give inflated type 1 error rate, including the power prior approach. And when the covariates are included in the model, the MPP maintains a nominal type 1 error rate of 5%. Actually, I didn't present it here, but the MPP approach gives now highest statistical power when the MPP maintains a nominal type 1 error rate. So the most important conclusions based on our study is that the dependent MPP reduced substantial number of subjects from required sample size, and the dependent modified power prior offers highest power, but at cost of inflated type 1 error rate. But it is difficult to select a single best method as the performance of methods depends on the actual setting of the data, which are often unknown in practice. And the other conclusion is that the dependent modified power prior is preferable to the meta-analytic predictive approach to have separate weight to each historical study. These are the main important conclusions. And the future research in this application or in this area is that since the computational aspect of the power prior approach is very difficult, further research is needed here, actually, and also robust or robustified version of the methods for the case of prior data conflict. That means when the historical data and the current data are vastly different. So in that case, robust version of the methods is needed, and future research or important research is needed here. And another recommendation here is that proper evaluation of the methods. There are some debates between so-called conditional versus unconditional operating characteristics to compute or to evaluate the methods. So here, further or future research are important actually. And the metrics that we use to evaluate the methods are mainly based on, say, the type 1 error rate, the power or calibrated power, and etc. But there are currently developed metrics called decision theoretic metrics, which is based on some costs or benefit of inclusion or exclusion of the historical data. So I think further research in this area is very important again. So these are my remarks. If you want to read more on this area, these are my published works, modified power prior with multiple historical trials for binary endpoints. This was a first paper. And the second, in the presence of covariates or confounding factors. So we again evaluated the methods for the power prior approach with, in the case of linear regression model. So you can see this. So thank you. I think you heard me well. I don't know whether the connection was fine or not. Thank you.
Thank you, sir. Thank you, brother. Any questions? Any questions for the speaker? Yes. Yes, there's one person raising his hand. Can you ask your question, sir?
Okay, thank you very much. Let me first of all appreciate the presenter for a very nice presentation. My question is, in one of the slides he has shown, there is a slide he showed independent MPP and dependent MPP.
Yeah.
Yes.
Okay. Not really this one. The one you gave a value for the independent MPP as 1, 1, 1. That's the parameter alpha beta being 1, 1 or 0.5, right?
Yeah.
0.5, 0.5, right?
Yeah.
Okay, this is it. This is it. So my question here is that for the independence, why do we have these two type of category of the values of the parameters being 1, 1 or 0.5, 0.5?
Thank you very much. Yeah, so this is in a Bayesian approach, it is somewhat different from the frequentist approach. So if you have a fixed shape parameter, say 1, 1 or 0.5, 0.5 or 2, 2 or different. So in that case, this parameter will be independent. That's a Bayesian way. Where it is hierarchical, say if you assume another hyperparameter, say alpha and beta, okay, shape parameter, in that case, this parameter becomes dependent because it assumes that they come from the same distribution. They have a common mean, a common variance, and etc. Okay, so in that case, it assumes that it is a hierarchical approach, and it assumes that the mean are the same, the variance is the same, so they have the same phasor. Okay, so they become dependent in this case. It is a little bit different from the classical approach that we know. So if you assume a hierarchical approach, it becomes dependent.
I see. Okay, thank you.
Yeah.
Any other questions?
Yeah, just to follow on that particular question, the independent MPP. So why I will feel that you chose beta 1, and beta 0.5, 0.5 because you want it to be distributed in a uniform sense, right?
Yes.
So the dependent one. Okay, I think that probably clarifies what I want to. Yeah, okay. That's all right then. That's a good talk, actually. Thanks very much.
Thank you. Yeah. But maybe to clarify more, in our work, we mainly focused on this part actually. But one can also assume the beta 0.5, beta 0. This is called actually Jeffrey's prior, if you know.
Exactly, the non-informative prior, Jeffrey prior, yes.
Yeah. In both cases, it gives you, it is an independent MPP. It means that the power parameters are independent. It means that they are distributed in a separate way.
Yes. Any other questions, guys? Any other questions?
I try to make it very short because there are many technical things here. So I think,
Yes.
yeah.
I think, yeah, your presentation is excellent. I mean,
yeah, thank you.
I mean, I think we need, the Africa needs more people like you, especially after, I mean, a lot of people who complete their PhD don't want to go back to their countries, and you have returned to your country. I think we need more people like you.
That's interesting.
Yeah, thank you. Yeah.
All right.
So, as said before, I also need some collaboration. Yeah.
Yeah, I mean, I for one will be very happy to collaborate with you. So I know your work is Bayesian, I know, but it's something that I can work with you too.
Yeah.
Yeah. All right, guys. So we will now take up a 20 minutes break. And we will start again at 4:10 UK time, which is about 20 minutes from now. All right, so let's take a break and we will rejoin in about 4:10 UK time.
Okay.
Okay. All right, guys, welcome back, guys. The next presentation is gonna be by Farai from Limpopo University in South Africa. Farai, are you there? Oh, okay, good.
Yeah, just a few minutes. I just want to see how okay, yeah, so I think I can start, right?
Yes, you can start now.
Okay, thank you, and I would like to thank the organizers for this wonderful opportunity for me to share part of my work. I would like to talk about the optimal production and regulation of gold mining, a stochastic differential game approach. And this work is a joint work with Takaya, and I am from University of Limpopo in South Africa. The outline of my talk is shown on the screen. I hope I will have some few minutes to talk about the African researchers and some experience if I have some time. So in terms of the motivation, let me, the exhaustible resources, natural resources that exist in limited quantities and can be depleted over time through consumption or extraction. And examples of these resources include oil, gold, coal, platinum, and ores, and these exist with finite total endowments. Therefore, there is a need for regulation of the exploitation or extraction to ensure a long-term sustainable production. And the earliest work that looked at the extraction of these resources can be traced back to Hotelling, where an optimal extraction policy under the assumption that the commodity price is deterministic was derived. So in this present work, I will examine a production and regulation of gold using a stochastic differential game approach. So first of all, I would like to show you the trend of the gold prices of the Anglo gold in South Africa. And this data ranges from 2013 until 2023. And you can see that during the COVID period, I think there was a decrease in terms of the gold prices. So I just wanted to highlight this. Then in terms of the formulation of this problem, here we would like to consider a mining company which enters into a long-term mining agreement with the government of a particular country. And this government, it will either collect some royalties from the mining company, and also it can also collect some income tax that it can levy to this particular mining company. And the gold mining company determines its rate of extraction, which we denote by U1 in this case, and the tax rate, I mean, that is levied to by the government to this particular company is denoted by U2, and is found in this particular space. So we will let alpha t, which denote a finite state Markov chain with a generator Q, and this alpha or this Markov chain, it actually captures the state of the gold marketplace and is not necessarily observable. And we'll let D to be the total size of the gold reserve at the beginning of the mining agreement, and Y, YT, the size of the remaining gold reserve at time T. And we denote by XT the price evolution of gold. Therefore, the dynamics of XT and YT are therefore given by this differential equation, stochastic differential equation, where mu here, the first term here, we have the drift term, and we have the volatility term. So sigma here, the volatility, and alpha of t is our Markov chain. And this U1 here is the extraction rate by this mining company. And we give this dynamics with this condition, where X is the initial gold price and Y is the total price of the reserve before mining. And this W is some Brownian motion, which is defined on the usual probability space. So next we will define what we call admissible controls. So we say the extraction rate and the taxation rate, they are called admissible controls with respect to some initial data, provided that equation that I have shown you has a unique solution with these initial conditions, and that the process U1 and U2 are FT adapted, and where the filtration is generated by this the state of the marketplace and the Brownian motion. And so if these two conditions are satisfied, then we say U1 and U2 are admissible controls. So next we look at the cost of extraction, which we denote by C, and the total profit rate of operating the mine, we denote it by P. And given a discounting factor L, which is positive, we then assume that the total cost function is given by this equation 2. And in this case, K is some initial cost of setting up the mine, and beta and theta here are just positive constants. And the total rate of operating the gold mine can therefore be calculated as the revenue that is generated by this gold mining company minus the cost of operating the cost of the extraction. And before tax, the profit of the gold mining company is therefore given by this quantity here. And while the government collects royalties royalties, so the profit rate by the government therefore will be given by this quantity here. And after tax, the profit rate then of the gold mining company will therefore be given by this expression. And while at least the profit rate for the government will be given by this equation here, where the first term is the profit that they get from the royalties, and the second term with the profit that they get through the taxation. So for a given discounted rate L, which is positive, we therefore define some payoff function for the mining company and for the government. So we will from now onwards call the mining company player 1, and the government will call it player 2, bringing up the issue of the game. So the payoff for the mining company is given by this equation 4, while the payoff for the government is given by equation 5. So this term here, under the integral sign, is the cost of running this particular extraction, while this is the terminal cost. And therefore, the problem is the following. So the gold mining company here, its objective is to select an optimal extraction strategy, U1, which maximizes its payoff functional, whereas the government's objective is to select an optimal tax strategy, U2, which also maximizes the payoff functional for this government. So the next definition that I'm showing you now is what we call the Nash equilibrium strategy for this game that we have just described now. So we say U1 and U1 star and U2 star, they are called Nash equilibrium strategy if this equation 6 and 7 holds. In other words, for equation 6, we fix the taxation rate because we are only focusing on the gold mining company, and then if the payoff functional for where U1 star is greater than the payoff functional where we just have U1 is satisfied, then we say that U1 is a Nash equilibrium. Similarly, for the case for the government. So if the Nash equilibrium exists, then so if a Nash equilibrium of the differential game exists in this case, and is given by U1 star and U2 star. Then we define the value function for player 1 to be given by equation 8, and the value function for player 2 to be given by equation 9, where we are just taking the supremum of the payoff functional for each. So what we then need to do is therefore to determine this U1 star and U2 star. And to do that, we initially have to calculate the value function V1 and V2, followed by the derivation of the optimal strategies. So what we do first, we define what we call the corresponding Hamiltonian equation for both players. So for player 1, we have this equation 10, and for player 2, we have this equation 10, where this generator is given by this equation down here. So the value function for player 1 and player 2, they satisfy what we call the Fleming-Bellman equation, which are given by equation 12 and equation 13. Again, equation 12 for the gold mining company, while this equation 13 for the government. Of course, with these terminal conditions given in equation 14. So once we have this setting, then the classical approach is first of all to define, to present what you call, or to prove what you call the verification theorem. I will just state it here without necessarily, without proving it, but it's a theorem which ensures that the solution for our problem actually exists, and it comes up with some condition, like we have some functional W which is continuous, and it satisfies some nonlinear Fleming-Bellman equation that I have pointed out, with the terminal condition also that are given in the slide, in the previous slide, as well as the quadratic growth condition which is given in this equation. Then we also define U1 star and U2 star by this equation 15 and 17. And we also suppose that this inequality holds. And so if that is the case, therefore the payoff functional for both, in this case I'm using K, where K is equal to 1 and 2, is actually less than this functional that we have assumed in our statement of the theorem. But where U1 star and U2 star, so this is for any U1, for any controls U1 and U2. But if we have the optimal strategy U1 star and U2 star, if we're able to find them, then this equation here in 17 is actually equal to 0. And if this is the case, then the dynamic that we have described, it admits a unique solution, and the pair U1 star, U2 star, therefore becomes our Nash equilibrium, and we have equality in this equation 20. So this is the classical result, that we will have to prove, but I will not present its proof in this particular case. So next, I then would like to present to you the closed form solution. So we assume that there exists a Nash equilibrium U1 star and U2 star. Then the solution of the FBI equation 12 and 13 that I've shown you earlier on are therefore given by that the value function is given by equation 21, and this is the value function for the government, for the gold mining company, and this one here is the value function for the government. So where A1 and A2, I will show you, they satisfy some system of equations, which I will show you just now. But before I show you, then the optimal strategy for player 1, therefore, is given by this equation 23, whereas the optimal strategy for player 2 for the government is given by equation 24. Then those A1 and A2, those constants that I have shown you that were in the value functions, are given by this system of equations 25 and 26. Again, I skipped the proof of this because it's quite lengthy, but I just give you a remark. But maybe I can skip this remark because of time, because I want to get to some of the things. So with this closed form solution that we have obtained, we then try to apply this to some real data. So we consider the gold mining company in South Africa with a known reserve of 10 million ounces of gold. And the South African government, it collects maximum royalties such that the mining company retains the value theta, which is 0.95. Then calibrating our model using the data of the daily gold prices from January 2018 until, sorry, I think here it was supposed to be January, not December 2023, of gold price company, we obtained the following estimates for our values. So we obtained the return vector or the drift coefficient, these values, and the yearly volatility vector, we obtained these values. And the generator of our Markov chain is given by this one. And our discount rate, the annual discount rate, we consider this value here. Then the extraction cost now, if we then put these values that we have obtained, we see that the cost of the extraction is given by this equation. And if the South African government collects a maximum tax rate that is 34%, then the value of for player one is given by this. Then we then have to calculate, calibrate or try to find the optimal extraction strategy, U1 star and U2 star, using that theorem that I have shown you. And the result that we got are the following: that the optimal revenues of the gold mining company when the tax rate is 34%, during the market uptrends, we were able to deduce that it takes this form, and the downtrends is take this form. Whereas when we consider the optimal revenues for the South African government, when the tax rate is 34%, the uptrend is given by this figure, and the downtrend is given by this figure. And the optimal daily extraction rates by the gold mining company were shown to be these figures, when the tax rate is 34%. And we also consider the case when the optimal tax rate is taken to be the minimum value of the income tax. And in this case, we were taking U2 to be 0. And the value function of player one again is take this form. And with this, we were also able to plot some figures which shows the optimal revenues of the mining company when the tax rate is 0% during the both uptrends and downtrends. And these are shown in these particular figures. So similarly, for the South African government, we were able to show these trends. So from these two cases, we conclude that it is optimal for the South African government to charge 34% corporate income tax to the gold mining companies. And even if the initial tax rate is set to be at 0, once the gold mining company reaches the optimal extraction rates, then the South African government has to respond by setting up the corporate income tax at its maximum value of 34%. So this is where there is some kind of funding that we get from this. And in terms of the conclusion, so we analyzed the production and regulation of gold mining company in South Africa using the stochastic control approach. And we formulated the model that described the interplay between the government and the gold mining company, and the corresponding Hamiltonian-Jacobi Isaac equations, which in our case is a system of nonlinear partial integral differential equations we explicitly solved. And we provided some cross-form representation of the value function and of the optimal control strategy. And we conclude that the South African government charges the maximum corporate income tax once the mining company reaches its optimal extraction rates. So this were the conclusion that we get from this particular study. But I would also wanted to mention this, maybe if I still have some few minutes, that I am the president of SAMSA, the Southern African Mathematical Science Association, and we will be having our conference that will be held at the University of Pretoria, South Africa, from the 21st to the 24th of November, 2023. And this conference, it covers almost all the mathematical sciences branches, statistics is part of what our delegates usually, present.
I'll ask him if they are funding for traveling.
Sorry, and what one can obtain some details about this conference on the link that I have provided. And I'm not so sure in terms of my time, Chair, because I want also to discuss briefly some African researchers and their experience. I don't know in terms of time, Chair.
Yeah, you have time. Yeah, you have.
Okay.
Well, yeah, you have a couple of. I can give you 1 or 2 minutes.
Okay, no, it's fine.
Yeah.
So in terms of the challenges that the African researchers find themselves in, I think there is the problem of access to reliable and up-to-date data for their research. And there is lack also of funding for research projects. And there is limited collaboration among, so researchers work, you find that some of the researchers, they are working in isolation. That's why earlier on I was recommending maybe if we are able to form some clusters so that we can see what we can do in terms of this kind of collaboration. And in some cases you may also find that the infrastructure and equipment. We do lack some of some high computing machines that we may need for our researches, and also access to scientific literature, journals, and databases due to high subscription fees that we may be required to pay, and our institution may fail to be subscribing to those. Yes. Then African researchers also seeking better opportunities and resources abroad. They also weaken the research capacity within the continent. Of course, I think the issue of the workload have already been said earlier on. And also we also have the challenge of supervision capacity, and which I think maybe by forming some kind of collaboration with those that are outside and maybe those that have better resources, I think we can also try to assist in and find ways in which we can deal with this issue. So these are some of the things that I wanted to share. But also maybe since you said I have one more minute.
Yes, you can have 1 more minute.
Yeah. Okay, all right. Yeah, if I have 1 more minute, let me stop sharing this one, and I quickly want to share this if I can find it. Where is it now? I thought I have. Yeah. Also, I am like I have said. I let me just quickly see if I can. I think I can find it now. Where is it? Okay, I think it's here. You can see my screen share?
Yes.
Okay, yes. Yeah, earlier on, I think Prof. Anotida has spoken and was talking about the UK APACY. I was also running another consortium, the SA UK University Capacity Development Program, which was a collaborative project. And in this particular project, we were focusing mainly on building capacity in applied mathematics. And in terms of some kind of funding, we got some funding from the Newton Fund and the Department of Higher Education here in South Africa, and some participating institutions. We had my university, University of Sussex, University of Johannesburg, London School of Economics in the UK, the University of Bath in the UK. So we have several institutions that were participating, and the main area that we were focusing on were the following: that we were looking at the disease modeling, financial modeling, ecology modeling, population dynamics, and wildlife management. And in terms of this particular program, the aim was to train about 10 doctoral students, and these doctoral students were are being supervised by some colleagues here in Africa and some colleagues in the UK and also in Poland. So this collaboration, I think that I am also advocating. It's something that we can also try to learn from, and also try to see where we can get some funding and try to do something for Africa. Sure. I think this is what I wanted to share, Chair.
Thank you, Farai. Yeah, I agree with everything you're saying, but I'm trying to do everything I can, 365, 24/7, working with people in Africa. But the question is, I mean, with all the, you're saying that there's a lot of universities in the UK and Europe working with people in Africa. But my question is, are they really serious? I mean, are they really spending their time every week, advising students in Africa or researchers in Africa? Or are they just doing it for their own benefit? I mean, that's my main question. I know we Africans, we are really, I mean, we do care about our brothers and sisters in Africa. But my question is whether the people in Europe or America who are involved in this project, do they actually care? Do they actually?
Yeah, no, but at the end of the day, the point is, for example, in the project that we are running, this is to do with capacity development of people in Africa. These students that I've talked about, they are all in South Africa, for example, and the academic staff of different universities here. And the idea is that once they obtain their PhD and they have this exposure of working with the expertise in their field, they then carry on with the research, and their research, I mean, in most cases are done here. And that will have an impact in terms of developing researchers in Africa, which I think is something that, of course, yes, there is that element that, of course, once they have done this, they will also, I mean, use it for their benefit, I mean, over that side in terms of it could be promotion, in terms of other things, or also in terms of coming to Africa. But that collaboration, once the students have graduated and are exposed to a number of fields in terms of the research area that they would be doing, I think it's something that we should also appreciate. But I would agree with you that yes, there is need for us to identify also some African brothers who are overseas, who are scattered almost everywhere, and come together and see what we can do so that we can develop, I mean, our continent as well in terms of the research.
Yes, thank you. Yeah, I mean, I really like to know. I mean, you said there are so many workshops. I mean, earlier the guy from UBC talked about so many workshops being held. I really like to know, like, what was the in terms of outcomes for the researchers, for the researchers in Africa, what did these workshops, bring about? I mean, did it lead to any significant publications for the brothers and sisters in Africa, or was it just like a publicity exercise for the people?
No. Yes. I think Pinsley also can testify, and there are quite a number. I have seen quite a number of colleagues here as well who were part of the UK APASI, and I think in a number of
I'm part of it too.
Yes, and a number of colleagues from Africa have actually benefited in terms of collaboration, because out of this collaboration, I think a number of the research output publication have also emerged from those workshops as well. Okay. The other colleagues can testify. There are quite a number of people who are here. I've seen. Yeah.
Okay.
That's true. That is true. Because I'm also part of UK APASI, and in our group we have one paper and we are working on one right now. And it has been a wonderful group so far. Very good collaboration is up like that. It's through the UK APASI I met Queensley, and we have done a lot of projects together. Through UK APASI, I met so many people, and we are still working and researching together. So the workshop is a very good place to meet people and collaborate and networking.
Okay, that's good to know.
Yeah, and I think I also would need to have your email. I don't see your name because I just see MBBSSN, but I would like to have your email so that if we have this kind of workshops, we can also invite you. You can come and see, and you can, also give your opinion in terms of how these things are running. Yeah.
Okay, Prof, can I ask a question?
Yes. You.
Okay, I want to ask Professor Farai. I want to ask in terms of Samsam. I've attended once and I've attended twice online, once physical and twice online. So I want to know what is like the first time I attended physical, I was sponsored. But most times you want to attend those conferences, your salary cannot even help you to travel. For you to travel most of these conferences, you have to save like 6 months salary that if you want to travel, because there's no funding for you to travel. How can we go about it? Because going for workshop become a problem. Most times I will enjoy doing online, but we know that physical attendance in a program has a huge impact in somebody's career. So how do we go about it? Is there any funding available for those workshops? Is there any funding available for the conferences that someone can have access to?
For now, I think we only have been able to secure some partial funding for students, for about 10 students. We secured some funding from AMSI, and this funding is some kind of partial funding. It's not to cover everything, and is to fund some students who will be able to come and also participate during the SAMHSA conference. I understand, yes, the issue of funding is a challenge. I mean, in terms of colleagues from other African countries, but colleagues at least who are in South Africa, there is quite a number of some funding opportunities that the colleagues from different universities here are able to access, that is made available by the Department of Higher Education here in South Africa. But I agree, yes, that we still have a challenge in terms of assisting our delegates to be able to participate in this conference. And it's something that we are trying to work on. And
okay. Farai,
yeah,
I think we need to go to the next presentation now. So
okay,
let Dalson. So Dalson is the next speaker. Dalson is also from Zimbabwe. I mean, I knew him at the University of Zimbabwe, but the talk is gonna be spoken by Edmo. Edmo, are you there? I'm not sure if Edmo is there. Edmo.
Yes, sorry, I'm here. I was muted actually.
Okay,
yes.
okay.
Yes. Can I open the talk from this side?
Yes, you can. Yeah.
Okay.
Edmo is also from the University of Zimbabwe. I've known him for quite a number of years now. He did his basic degree at UZAT, and then he went to South Africa to do his PhD. Currently, he is a full professor at University of South Africa in Florida campus in Johannesburg. Okay, over to you, Edmo. Take it from there.
Thank you, Sarah Liz. I just want to minimize that. Okay. I wanted to minimize the top part here.
Yeah, it looks okay. It looks fine.
It looks fine.
Yes.
No, I can't see that actually. I can't see the top part of my screen. Okay, fine. Okay, the presentation is on the use of Bayesian statistics methods and quantile regression analysis to correct effects of stroke modifiable and non-modifiable predictors measurement error in logistic regression models. A hospital-based study in South Africa. And this is the work we are working together with Linus, me and Linus are from the University of South Africa, and Dawson from the University of the Free State, which is a powerhouse in Bayesian statistics. Whilst here at UNISA, we are also strong in quantile regression. So here's the introduction. In South Africa, stroke is the second major cause of death after HIV and AIDS. And it is among the top 10 leading causes of disability in South Africa. It also accounts for 25,000 deaths yearly in South Africa. And South Africa is experiencing a rapid health transition characterized by increases in stroke disease. Yet little is known about the modeling of modifiable and non-modifiable stroke predictors using appropriate statistical techniques. All right, predictors of stroke such as hypertension and diabetes are usually measured with error, what we call measurement errors in the covariates, which are usually ignored in analysis, resulting in biased results. And Bayesian statistics is a common measurement error correction method used by public health researchers. Bayesian logistic regression, logistic quantile regression measurement error techniques were used in this study. Identification of stroke predictors using appropriate statistical methods can help formulate appropriate health programs and policies aimed at reducing the stroke burden in South Africa. Study results will be used to develop public health interventions such as campaign awareness on risk factors and possible measures to reduce the burden of stroke. Right, you can see from the pictures, which actually speaks more than 1,000 words, how people are incapacitated from the pictures that you see here on the slides. Risk factors of stroke can be classified as modifiable and non-modifiable. And modifiable risk factors are controllable, such as hypertension, cholesterol, smoking, and heavy alcohol consumption. And non-modifiable risk factors are natural factors such as age, gender, race, and genetics. Analysis of stroke predictors have, in the main, concentrated on the mean regression, despite its limitation of focusing only on the conditional mean of the stroke distribution, which is actually the center of the distribution. You know, but we know that actually it is important also to model maybe in the tails of the distribution in some instances. Most studies identified stroke predictors using binary and multivariate logistic regression. Quantile regression has emanated as a useful additional technique to either binary logistic regression or the classical linear regression. Quantile regression is a statistical technique which commonly in fact, actually, it's actually an extension of the well-known median regression, which is called the L1 estimator, and estimates the conditional quantiles, you know, in the whole interval from 0 to 1, while its ordinary least squares method focuses only on the conditional mean. A cross-sectional study design was used to identify and quantify the modifiable and non-modifiable predictors of stroke in South Africa for the period of January 2014 through to December 2018. The data was retrieved from the South African Public Health and private hospitals that were sampled. The response variable was confirmed stroke, and the independent variables were demographic information, race, gender, age, hypertension, cholesterolemia, heart problems, and diabetes. The Bayesian approach to quantile regression was used because it provides estimations and predictions which take into account parameter uncertainty. Data analysis were done using SPSS version 29 for descriptive statistics on the demographic information and predictor variables. Bayesian approach to quantile regression is normally carried out by formulating a likelihood function based on the asymmetric Laplace distribution of the data. Generally, any prior can be chosen for each of the quantile regression parameters, but it has been shown that the use of improper uniform priors produces a proper an improper joint distribution. I think it was supposed to be improper there. Bayesian quantile regression approach produces exact inference and accommodates missing clustered or censored data. The Bayesian binary quantile regression models were estimated by the use of MC-MC-PEC. The coder package was then used to run diagnostic tests of convergence. Why Bayesian quantile regression? Right. Quantile regression makes very minimal assumptions on the form of the distribution. Thus, is able to accommodate non-normal errors. You know, in the classical case, we know that normality is always assumed, but in this case, you can assume any distribution, the error tends to follow any distribution F. Quantile regression provides more complete description of the functional changes than focusing only on the mean. Like I've said, that you can actually get the range of all quantile hyperplanes or quantile lines, you know, from 0 to 1, depending on the interest of your research. And Bayesian framework allows individual specific parameters for cognitive function to be estimated using Markov chain Monte Carlo measurement error models. Sorry. In this study, Bayesian binary quantile regression shall be adopted. Bayesian quantile regression is a sensitive alternative to classical quantile regression when making inference on underlying quantile regression functions. The use of Bayesian binary quantile regression is motivated by the fact that the frequentist approach to this type of regression has proven to be a challenge in optimizing the objective function. Binary quantile regression provides a much richer view of how covariates influence the response variable. Now, Bayesian approach to quantile regression was implemented by adopting the MC-MC algorithms contained in the R package MC-MC-PEC. Models produced by MC-MC-PEC return coder MC-MC projects that can be summarized by the coder package. The coder package provides functions for summarizing and plotting the output from the MC-MC simulations, as well as diagnostic tests of convergence. MC-MC algorithms have emerged as useful and popular tools for fitting Bayesian statistical models in modern Bayesian computing. The main reason why MC-MC algorithms have become useful and popular is that the algorithms can fit complex models easily as compared to standard techniques such as the maximum likelihood estimation. Here is the representation of the quantile regression, logistic regression model. So let's Y be the outcome of interest, that is our confirmed stroke in this case, and X be a vector of observed covariates, actually a matrix of observed covariates. We can model quantile, the conditional quantile of Y given X using a quantile logistic regression model as Q theta pi equal to y is equal to the transpose of the covariate matrix vector xi times beta tau plus the error term epsilon I tau. And here, your beta tau, which is your population regression quantile vector, is denoted by the intercept. And I think I want to emphasize the difference between your ordinary least squares vector, coefficient vector, and this one that corresponds to beta tau for the regression quantiles. So you see this quantity F inverse tau is the only one that differentiates the least squares beta tau beta vector from the quantile regression beta tau vector. As you can see that this is the usual intercept. Of course, if this F inverse at is equal to 0, for example, if the distribution is symmetrical, we know that then this passes through the beta naught, if F inverse is tau, the F inverse of tau is 0. And this is the only shift for the intercept. In other words, if your data doesn't have any aberrations, it means that your regression quantile hyperplanes will be parallel, which with this is just the distance between the adjacent quantiles, which is F inverse tau, which can be any distribution, doesn't have to be a normal distribution. So that's what we call your beta naught tau, which is your intercept. And this is the slope vector. The slope vector has got beta 1 to beta p, which are the number of covariates in your model. And of course, pi is the probability of y equal to 1, which is the probability of actually developing a stroke. And yi is the ith confirmed stroke individual. And now we have got your vector, your row vector from the design matrix. The ith row vector is denoted by xi transpose, right? For individual I. And we've already said this is our error term, epsilon I tau. And tau, in this case, we specifically took tau at the 10%, the 25%, and of course, the median regression, the L1 is meta, and then the 75% and the 95% quantiles. And this implies the vector beta is fixed while the intercepts with the quantile regression are parallelized. That is, if you don't have any thing like heteroscedasticity, which actually would cause these these lines or hyperplanes to cross sometimes in real life data. Demographic and baseline characteristics of stroke patients. So here we've got the variable, and here we've got age groups, and the percentages and the numbers also. The percentages are given in brackets, and these are the actual numbers from our sample, which is n equal to 35,730. And from 18 to 54, we've got 54.5%, and from 55 to 75, we've got 29.2%. From 76 to 98 years, we have 16.3%. And similarly, for the gender variable, we have got male and female, with male corresponding to 49.2% and female corresponding to 50.8%. And the rest, we have got black, white, and then the black race is 29%, 29.6%, and the white race is 34.3%. And Indian, Asian, we've got 21.6%. And here in South Africa, we've got a race that we call colored. Maybe I know that in Europe and America, they don't have it. This is 14.6%. And the variable hypertension, those that have hypertension are 55.3%, and those that have heart problems, they are 54.4%, and of course, the other the remainder from the 100% would be actually the other result for those that don't have. And diabetes has got 62.1%, and cholesterol we've got 47.4%. And now we've got a multivariate logistic regression model that we have here for modifiable and non-modifiable stroke predictors. And we have got our confidence intervals. And in this case, you can see that they are all significant, except in this case here, which is colored. Okay. And we've got the odds ratio next to it and the associated p-values. Okay. And you can see that this corresponds to the colored race. The p-value is greater than 0.05. Now we also have for the multivariate, the classical quantitative logistic regression model for non-modifiable stroke predictors. The classical quantitative regression model, you see as well that we don't include, one is not, zero is not included in all these, with the asterisk this indicating the significance of all the covariates here. Except here in the last row here, as you can see, the confidence intervals and also the absence of those asterisks. Right, we have got also, we've looked at the classical case. Now let's look at the Bayesian logistic quantitative regression and the 95% credible intervals using the MCMC method for modifiable stroke predictors. And as you can see, here, the colored race again is so there's some rough agreement actually between the classical case and the Bayesian approach. Still the colored race you can see, right? And diagnostic tests of convergence, convergence occurs when the generated Markov chain converges in distribution, the posterior distribution of interest. In this study, convergence was assessed using the trace plots and density plots. The convergence diagnostics are meant to check stationarity of the Markov chain and verify the accuracy of the posterior distribution. All right, so these are the plots that you can see, which verify that. A pen has just appeared here by mistake. Let me cancel it. Do like that. Right. This is the trace and the density plot of more modifiable predictors. Trace plots is a time series plot of parameter, say mu, that we monitor as the Markov chain proceeds. The study trace plots were obtained by running the Metropolis Hastings algorithm for 100,000 iterations, discarding 20,000 as pen in. from the figure above, it can be seen that the chain mixes quite well. Then conclusion, the identified predictors can be used to raise awareness on modifiable predictors and promote campaigns for healthy dietary choices, and modeling modifiable and non-modifiable predictors using multivariate quantile linear regression modeling up and Bayesian quantile linear regression could be beneficial for addressing stroke burden in South Africa. In summary, the gender female age groups 55 to 75 and 76 to 98, Black and Indian Asian racial groups, hypertension, hypercholesterolemia, heart problems, and diabetes had a greater impact and significant effect on stroke distribution at the upper quantiles. Another important study finding was that modifiable predictors such as hypertension, hypercholesterolemia, heart problems, and diabetes were found to be significantly associated with stroke across all quantiles. The prevalence of hypertension increases with age in Black South Africans, mainly due to high urbanization with the adoption of westernized food and lifestyles to bad dietary habits, physical inactivity, and obesity, which actually the much of the people migrating to urban areas happened after 1994, after the independence, after post-apartheid. And so you can see the effects.
Okay.
And the recommendations, I still have a little bit of time, is it?
I think you're already over the time, Edmar.
Okay.
Yeah.
The study, okay, can I finish quickly?
Yes, of course, of course.
The study, thank you, sorry. The study findings showed that strokes were attributable to established modifiable predictors and could be prevented by any early intervention system such as a regular screening and treatment of hypertension, cholesterolemia, heart problems, and diabetes.
Mm-hmm.
The significant modifiable predictors in South Africa are diabetes, hypertension, heart problems, and hypercholesterolemia. The study recommends regular screening and testing and treating of hypertension, hypercholesterolemia, heart problems, and diabetes in South Africa in the Black population in particular, to detect the risk of stroke early enough. It is therefore important for early detection and treatment of hypertension in South Africa to reduce the burden of stroke. Future clinical trials focusing on treating hypertension at earlier stages are urgently needed in South Africa.
Mm-hmm.
So these are the references.
Okay, thank you, Edmar. Any questions?
Yeah, I quickly want to add something. I think Prof. Rangana, you probably forgot to emphasize the basis of comparison. The colored race there, the variable was insignificant in most cases because of the basis. The basis was the white race. So it meant that whites and coloreds, they are, what do you call it again? They are not as prone to stroke as the other races. And there's no difference between whites and coloreds when it comes to the probability of developing stroke.
Okay.
Thank you.
Yes, okay.
Okay, I have a question, Edmond. That's a very nice talk, and I remember you've done some interesting work on quartile regression. I just want to ask a question about table 2. Could you just quickly, let's go to table 2. I saw some things there.
Table 2.
Yeah, so there's this comparison. Yeah, this where we have, yeah, this one. So when you had colored rays, because sometimes we do have issues with, logistic regression and things like that. But at times they are just good models that could answer interesting questions without having to do complicated things. So if you look at the coefficient that we have for colored rays, it was quite high and the odd ratio was quite huge. So you will never, under any guise, have a p-value that is going to be significant, because the problem now is that we have some problem of rare events here where you don't have enough information for the colored rays. And because of that, right, the standard errors that you will have for this is growing faster than the parameters itself. So there's no way the p-value will be significant. So that might be the problem that we've seen with logistic regression in this case. So what I would have recommended that you probably also try is models like the PhET penalized regression, which takes into account when you have this kind of imbalance in categorical data. So that might alleviate that problem.
Yeah,
Yeah, very, very correct.
Thank you for coming in on that point. In fact, we did experience a similar problem. We had, I think, Indian as a category, and then we had the other Asian races. But the other Asian races in South Africa were very few. We then ended up combining the other Asian races with the Indians. That's why you see Indian Asian there.
Okay.
So you tell me, if we were to group the colors maybe with the whites, would that solve our problem?
No, ideally, sometimes, this kind of variables, you might want to see their effect, the natural effect, without modeling things together by putting categories together. So that's what I'm saying, that this approach, like the PhET penalized regression, which does nothing other than trying to do something that looks like a Bayesian analysis using an Jeffrey Pryor, right? So that's what it's doing, but from the frequencies perspective, that will solve that problem.
Okay.
So you will not need to collapse
So it will
categories.
solve our small sample size problem.
Yeah, it's a small sample problem. Yeah, some small sample size problem. Yes.
All right.
Okay.
So we can talk about this later. Let's just go on with ours. Yes.
All right,
Yeah,
guys.
but-
Guys, we need to move on now, right, to the next presentation. You guys can talk about this later. Right, the next presentation is by Samuel from Ghana, I believe. He's gonna talk about. Samuel, are you there?
Yes, I'm here.
Okay. So he's gonna talk about the impact of climate policy uncertainty on the economy of West African countries.
So can I share my slide now?
Yes, please.
Okay. Yes, I believe that you can see my slide. I'm somewhere
I think maybe Edmond need to take down the
Edmo, can you take down your slides, please? Edmo. Edmo, are you there?
Let me do that, sure. Let me take down
I'll just click on stop sharing.
Okay.
All right. Okay, welcome, Samuel. So
Yes.
We can see your screen.
All right. Thank you.
Thank you.
So I'm Samuel. I'm from the Kwame Nkrumah University of Science and Technology, and I'm here to present on the impact of climate policy uncertainty on the economy of Africa. So this is the roadmap of the presentation. We talk something briefly on climate policy uncertainty. We talk about how climate policy uncertainty affect the economy of West Africa. We also talk about the motivation of the study, the data and the methodology used, the results, the conclusion. We do some suggested solutions. And if there are questions, there will be questions and answers. So climate policy uncertainty. In recent years, there has been a serious climate problems that have not only caused concern, but it has also posed a threat to the economies of most countries, especially for developing countries in sub-Saharan Africa and underdeveloped countries in sub-Saharan Africa. And countries worldwide have actually adopted the relevant climate policies to actually tackle greenhouse gas emissions, especially carbon dioxide emissions, nitrogen or nitroside emissions. But in order to actually promote sustainable growth. However, there may be many shortcomings in the development of climate policies by different governments. And as such, the focus of many governments have primarily be on the cost of the policy implementation when trying to develop and implement climate policies. And they actually ignore the uncertainties that may exist on the path of climate policy implementation, which is actually climate policy uncertainty. For climate policy uncertainty, for example, the US government has frequently joined and then withdrawn. Even recently, during the time of President the past president before the current president, actually, he withdrawn from the Paris Agreement in some recent years, and this kind of uncertainty caused by such policy adjustments often impacts enterprises more critically than the policy itself. So climate policy uncertainty, by definition, is the lack of clear and stable policies, regulations, or government actions related to addressing climate change and reducing greenhouse gas emissions. So how significant is climate policy and its impact on economies? First of all, on economic vulnerability to climate change, we see that extreme weather events and shifting climate patterns can actually disrupt key sectors of every economy, for instance, in the agriculture sector. And of course, when it impacts the agriculture sector, there will be a food shortage, which actually calls for global food insecurity in most parts of Africa. And of course, directly, these type of events can actually strain the national budgets. And of course, there will be some resources that might be targeted for education, but because of the food insecurity, these kind of resources will have to be rechanneled to maybe agriculture in order for the citizens not to starve and die. For economic opportunities, we say that climate policies can actually create a lot of economic opportunities. For instance, in the energy sector, it can actually promote the development of renewable energies, clean technologies, and of course, recently, sustainable agriculture, or even climate smart agriculture. And of course, we know that these particular sectors can have a potential to generate new jobs and also foster innovation, which will actually boost the economic growth and economic activities of most countries in Africa. On the part of the energy sector and transformation, it's obvious that the energy sector plays a vital role in climate policies, transitioning from fossil fuels to cleaner fuels, or even from diesels, petrols to electric cars. We are witness of that the energy sector plays a pivotal role in climate policy. And this will actually help to reduce the amount of greenhouse gas emissions across the globe, not only in Africa. And the environmental cost. There is actually an environmental cost if climate change is not actually dealt with properly, including habitat loss, maybe some biodiversity declines, including the change of seasons, especially recently in Ghana, we have witnessed a drastic rainfall changes. In periods like this, we expect that there will not be much rainfall. It will be heading towards the season of the dry season. But even as I speak, there is still rainfall. And there is an environmental cost to that. This has even caused flooding in most parts of the country, causing a lot of grief around such places. How does climate policy uncertainty affect the economy of West Africa? Because our study is basically targeted on West Africa, we want to know some of these climate policies, how the uncertainties, how it affects the economy of West Africa. For energy, for instance, in a recent study by Shah et al. In 2022, the authors actually indicated that climate policy uncertainty reduces the demand for non-renewable energy. And it, however, positively affects renewable energy demand in the long run. But in our situation in West Africa, it is clear that the usage of renewable energy is very limited. So therefore, how does this climate policy uncertainty, how will it reduce the demand for non-renewable energy? Since we don't have an alternative of a renewable energy. So therefore, the inhabitants of most of these countries will still have to use the non-renewable energy. In terms of agriculture and food security, the role of climate policy uncertainty in the agricultural product market cannot be ignored. Uncertainties about climate policies may seriously affect the output and price of agricultural products. And this could potentially hinder the farm income of most smallholder farmers, which can cause economic uncertainty to most farmers. This is particularly obvious, for instance, in my country, Ghana, when you go to the northern part of the region, where farm inputs, there are a lot of losses because of the changes in climate, and this causes economic loss to most of these smallholder farmers. In terms of trade and international relations, climate policy uncertainty do affect trade and international relations. Typically, this was seen, as I previously said, in the era of President Trump, where he promised to withdraw from the Paris Agreement, an agreement that is being signed among about 194 or 195, I think, nations to actually cut down greenhouse gas emissions. And, you know, cutting down greenhouse gas emissions will actually help to avoid the worst impact of climate change. On investment and capital allocation, climate policy uncertainties actually weakens investment incentives for low carbon technologies. And of course, uncertainties could lead to investment choices that will actually lead to suboptimal in a world of greater climate uncertainties. What is the motivation of our study? We want to actually check whether the uncertainties of climate policies will disrupt the economies of West African countries. Does climate policy uncertainty, does it have an impact on the economy of West African countries? This is particularly interesting because there has been work done on other parts of the world, but for that of West Africa and Africa as a whole, there has not been much study on such, to the best of my knowledge. So what are some of the effects, or what are some of the impact, both short-term and long-term impact of climate policy uncertainty, or are there impacts of climate policy uncertainty on the economies of West Africa? To it, the objective of the study is therefore to assess the impact of climate policy uncertainty on West Africa's economy. And we will want to know whether energy use, population, carbon dioxide emission, and the number of international tourism arrivals, when they are controlled, does this impact still exist? And if they are not controlled, does this impact still exist? So the methodology, we will make use of a data of climate policy uncertainty, which was obtained from Gravilius 2021. We also make use of some control variables, of course, the GDP, which is the gross domestic product. We are using that as a proxy for the economy. And there will be some control variables here. We use energy use, population, carbon dioxide, international tourism, and number of arrivals. The methodology, or the method that will be employed for the analysis, is the wavelet coherent analysis. And some of the benefits of the wavelet coherent analysis is that it allows for causality and correlation. It also allows for multivariate analysis. It also allows for time frequency analysis, and it helps in identifying patterns and their coherence. However, I should be fast to say that for the wavelet coherence analysis, when you are dealing with two or more variables, you can actually detect the impact, but the direction of the impact, whether being positive or negative, cannot be detected. So we want to know the impact of climate policy uncertainty and energy use on gross domestic product, or since gross domestic product is serving as a proxy for the economy, we want to know the impact of that on the economy. So, okay. So when we look at the plot, clearly we can see a very red shaded part on the upper part of the plot. This shows the correlation, or this shows the amount of impact. So here, the upper portion of the graph shows the short-term impact. The lower portion of the graph shows the long-term impact, and the middle portion of the graph shows the medium-term impact. So since there was, and when you check the color bar, see that the red part of it ranges from around 0.7 to 1. That shows that there's a very high correlation. So here, when we are to read this particular graph, we can see that the combined impact of climate policy uncertainty and energy use on the economy of West African country in the short term is very strong. And it's very strong from the period of 2004 to 2022. However, when we want to talk about the long-term impact, there is some long-term impact that can be observed, but this long-term impact can actually be felt after 2014, where we can actually see some red colors at the bottom of the graph. So we say that there is a combined impact of climate policy uncertainty and energy use on the economy of West Africa in the short term. And this impact is actually felt from 2004 to 2022. And then what is the impact of climate policy on the economy when energy is controlled? When energy is controlled, clearly there is a short-term impact. But we can see that the short-term impact reduces from the earlier 2004 to 2022 to around 2015 to 2022. And that is when energy use is controlled. So if we control energy or energy consumption, the impact of climate policy uncertainty on the economy of West Africa is actually strong from 2015 to 2022. And what is the impact of climate policy uncertainty and carbon dioxide emissions on GDP? Well, a very strong impact, which ranges from 2006 to 2022. And of course, the long-term impact is also very strong, but it's not as strong as the short-term impact. And we can also observe some medium-term impact around 2018. What if, okay, is my screen sharing paused?
Yeah, I can see that the screen is not moving. Yeah.
Okay.
It's okay now.
It's okay now.
Yeah, I think
yes.
Yeah.
So, yes. So I was talking about the impact of climate policy uncertainty and carbon dioxide emission on the economy of West Africa. And clearly from here, there is a very strong short-term impact between 2006 to 2022, and also a a long-term impact, which is also very strong from around 2016. And also there is a medium-term impact from 2006 to 2022. But when carbon dioxide emission is controlled, the impact of climate policy uncertainty on the economy of West Africa is not actually felt because there is a very weak short-term impact of climate policy uncertainty on the economy after controlling for the effect of carbon dioxide emissions. And this shows the importance of carbon dioxide emissions in the economy of West Africa, and that of the impact of climate policy uncertainty and international tourism on West Africa. The long-term impact is actually felt very strongly. That is, even from 1990 all the way to 2022. A very strong short-term impact, a very strong long-term impact is actually felt. Okay.
You got about 4 minutes. You
okay, yes.
try to.
Yes.
Yeah.
So for the impact of CPU on GDP when population is controlled, clearly there is not so much impact on that. You can see the blue lines, which shows not so much impact. And the combined impact of CPU and the other variables on GDP. So when we check the control variables together with the climate policy uncertainties, we can see that for both the short-term, medium-term, long-term impact, there is actually a very strong impact on the economy of West Africa. So the conclusion is that this study, we seek to review the impact of climate policy uncertainty on the economy of West Africa. And when we consider the combined impact of climate policy uncertainty, we saw that the magnitude of the impact was very strong. Magnitude of the impact on the economy of West Africa is very, very strong. And as such, we suggest that there should be a regional cooperation, or we should strengthen our regional cooperation. And also we should try to involve ourselves in green finance and investment, because we're doing a study and we saw that among the West African countries, it's only Nigeria, for instance, that have an act for green finance and green investment. We should also enhance climate resilience, and we should also make long-term plans development, and there should be public awareness and education. Thank you.
Thank you, Samuel. Yeah, very, very interesting talk. Any questions for Samuel? Any questions?
Yeah, just some kind of clarification. Hello?
Yes.
Hello. Yes,
Yeah.
I'm here.
Yeah, just a kind of clarification. The climate policy uncertainty. How was that measured?
How was that
measured?
Oh, yes. Thank you. Like I already stated, the climate policy uncertainty, the data for the climate policy uncertainty was actually obtained from a climate policy uncertainty website. And how it was measured was that, they measured this particular data. China has its own climate policy uncertainty, but we took the climate policy uncertainty of the US.
Okay.
So it actually It's just the newspaper reviews. Some comments maybe from past governments, from senators about whether to withdraw from maybe the Paris Agreement, for instance. Maybe Bush said something about climate policy, why it is not important for them to join. Maybe, people's comments, people of high pedigree, that's when they say something can have an impact. So they actually use this kind of information to measure the uncertainty of the climate policy.
Yeah, perfect. Thank you very much.
Adam, you have a question, Adam?
Yeah. Well, it's just a few. Sorry, please. My question is with regard the CO2 emission. I don't know. Yeah, does that has any impact or effect to the population? Because I realize it's one of the variable, and so I just want to know what is its impact on the GDP? Is there any impact it's made on the GDP, or why do you intend to use it here?
Yes, we could have just checked for the impact of climate policy uncertainty on GDP without taking any control variables. But we actually wanted to take some control variables. Those variables were actually taken from literature. We wanted to take them to know if those variables are controlled, what will still be the impact of climate policy uncertainty on GDP. And for instance, when we look at the impact of climate policy uncertainty and carbon dioxide emission on GDP, the short-term impact actually ranged from 2006 to 2022, for instance. But when this is a combined impact of CPU and carbon dioxide emission on GDP, and the short-term impact ranged from 2006 to 2022. But however, when we controlled carbon dioxide emission, we saw that when we controlled carbon dioxide emission, the impact of CPU on GDP actually derailed from the previous 2006 to 2022 to somewhere around 2016 to 2022. So clearly, carbon dioxide emission was also aiding in the impact of climate policy uncertainty on GDP. So if there is a combined forces, for instance, carbon dioxide emission, climate policy uncertainty on the GDP, the impact on such will be highly felt than when maybe carbon dioxide emission is only controlled.
Okay, thank you, brother. All right, I think we need to move on to the next presentation. The final presentation today will be by my colleague, Olatunji Johnson. So it's gonna be a general discussion topic. The topic is gonna be ways to connect academic researchers' theoretical expertise and innovation with that of professional statisticians, real world hand-on experience. Over to you, boss. All right.
Hi, everyone. Yeah, it's been a very long day. Good to see everyone. It's going to be a discussion, really. So I've only prepared a very few slides, probably five, I think, just to aid our discussion. And a lot have been said today, really. A lot have been said about the challenges, but today I will just be talking about a very simple topic, bridging the gap, connecting academia and real-world statistics.
Yeah.
So what is the gap that we are talking about? So the university, the academia, we know how to do the theoretical stuff in statistics. We know how to develop models, how to criticize models, how to explore models, how to develop methods, how to even publish papers. And in real world statistics, basically what they do there, they just solve real problem, even though they might not be solving them carefully. But
they solve real problems, because they want results now and then they want to make decisions. So basically they want real-time results. They are dealing with complex data actually in most cases, and they basically just focus on the result. They don't really focus on the assumptions they've made in the model. That is, they don't try to critique the assumptions they've made or even validate some of the models. They basically just want something. So there's a disconnect between these two groups, the people in the industry organization and the government agency and the people in the university. How there's this gap, and why does this gap actually exist? As I've mentioned, one of the reasons could be because the way we receive the training in the university, we just receive training to just do research, publish paper, and that's all. Like probably do probability theory, do spatial statistics, and that is it. We don't think carefully, we don't reflect carefully about how is this actually useful? How can I actually make this useful in the real world? How can I actually combine what I know with what someone else is doing to make a very big difference? So we don't have that time really. And as many people have mentioned today, we are given a lot of teaching to do, probably not me, but a lot of people in academia, they're given a lot of teaching to do. Another point could be publishing pressure. If you're in a setting where there's a saying that people say publish or perish. I don't believe in that anyway, but there's that culture that you just need to put out something there actually without actually thinking about the impact of what you're actually publishing, or other ways that thing could actually, probably in another field that thing could be useful or can actually make huge impact. Another reason why that gap exists is probably because of lack of real world exposure, which someone have actually mentioned today. That, in fact, I've heard this from my mentor many times. As a statistician, you actually need to be working with, for example, because I have my background in statistics and epidemiology, like we need to be speaking with the clinician. We need to be speaking with the core epidemiologist. Like we need to be designing studies together. We need to be advising them, even as they are conceptualizing studies. We need to be doing things together. Not that we have the data and then they send the data to us. We have to be part of the process. So sometimes lack of first-hand experience, lack of real-world exposure, sometimes could, people in the academia might not actually, even though you might be doing very good science, you know the method, you're doing very good research, but you probably not appreciated the way it should, because you're not, probably because it's not known, they don't know it's there, or because you don't even know too that it could be applied to in certain areas. The communication gap, essentially, we need to be talking to them, as I've said. We definitely need to be talking to people in the industry, people in the government agency. We need to be talking to them. And then limited collaboration. Probably as part of my training, you definitely need to work with people. Even though I had my PhD in statistics and epidemiology, I don't always pride myself as an epidemiologist. I see myself more of a statistician than an epidemiologist. But at the same time, anytime I'm thinking about a problem, I always think of, oh, who's an epidemiologist that I can speak to, that can actually critique this idea, with someone that can actually speak to actually see if this thing actually makes sense in the real world. So limited collaboration, like some of us, we just do our thing and then we just go. We don't think of talking to people that could actually make sense out of those things that we are doing. So, and this is where this talk will be interesting. How do we build the bridges? We've talked about the disconnect between these two groups, and then how do we build the bridge now to connect these two people together? Because it's a discussion, I'm just going to pause here. I'm just going to hear some few thoughts from us. I want people to just, I can't see people if you raise up your hand, but probably just unmute yourself. How do you build these bridges between people in the academia and the people in the industrial government organization. Yeah, I can say Farah. Go ahead, give it a go.
Farah, yeah.
Yes, thank you. And this is quite interesting. And yeah, maybe my contribution will be that the first thing that we may need to realize is that the people who end up maybe in those professional, like what we call those professional statisticians, or who may end up in those sectors, they come from us. So I think I just want us to realize that the student that we train, they will end up in those companies. And then there is a need for us to try and make some kind of networking with these people from the industries. And I would like also to give an example. This happened here in South Africa. It was a conference for mathematics of finance that we held every 3 years. It's an international one. And for this particular conference, we bring together colleagues from industries, from banks, from financial markets, from investment, quantitative analysts, together with the colleagues from the different institutions around here. So, and during those talks, and the idea is to try and also understand the kind of problems that the industries are interested in, and then try to see how we can work with them. And one other thing that came during this conference that I'm talking about, some students were presenting on some particular aspects that concerns what's happening in the industry. And one of the challenges that they were mentioning was the access to data. And from amongst the audience, some colleagues from the industry, they actually say, no, this data that you are struggling to get, I can actually provide you with, which is quite important. And I think if we can also try something like that, I think we can, try to bridge the gap. This is my first contribution for now. Thank you.
Thank you very much. That's an excellent one. Who else want to say something? Who else want to say anything? How do we build these bridges, the bridge to connect these two people together? Who else want to say something?
I just want to say something, Olatunji.
Right.
If you are talking about Africa, there is a need for practicing statisticians in Africa more than any other continent, because there are so many problems affecting Africa: diseases, floods, all kind of environmental disasters, on top of all kind of diseases. So we need statisticians to identify. For example, you should take malaria, for example. Find the factors that influence malaria, identify the factors that influence malaria, and similarly for tuberculosis. So we need, I know it's not professional statisticians, but we need people. We need people in the ground who can do the work of identifying the major factors, so that some remedial actions can be taken to curb the flow of these diseases, right? So I think, you know what I'm trying to say. It's really, I think, more than any other continent, because Africa suffers a lot from all kind of natural disasters and man-made disasters, and statistics can play a huge role in trying to tackle these problems, trying to find what the root causes are, or trying to minimize these things from happening in the future. So I think if we can use our expertise as academic statisticians and work with people on the ground, that would be a huge benefit to the people in Africa. I think.
Thank you very much.
Yeah.
Thank you, Sir Alice. I'm just going to rush through a few points that I noted down. I know we've got a lot to discuss.
Yeah.
One of the things we could do is collaborative projects. As a statistician, you have to be thinking, if you know you are more, if you are more into finance, you have to be thinking of what industry do you want to be speaking to? Do you want to be talking to? If you are epidemiologist, like, if you are more into health, do you have people like there are NGOs? There are a lot of research institutes, health institutes in Africa. There are a lot of people, even there are a lot of projects going on. Even in your university, there are a lot of researchers that are in public health in your university there, which you need to be talking to.
Yeah.
To contribute to make practical contribution with your expertise to practical problems. Another thing is internship program. To be honest, one of my goals is that my personal goal is that at some point, probably during my sabbatical, I'm going to spend some time in the industry. Which industry, I don't know for now, but I know at some point I need to spend my sabbatical somewhere because my experience is that when I read about great statisticians, some of them actually, if you notice how they became famous statisticians, some of them actually solve real problems that have not been solved before. And I can tell you, even though I've not worked in any industry before, there are real problems there because they don't have time to solve them really. There are real world challenges there that they want to solve, but there's nobody to solve it. So internship programs, as if you're lecturers too, we should encourage our students to also engage themselves in internship. Workshop and conferences like what we are doing now is a very great avenue for for building bridges. One, what we're doing now is that we're connecting at least across, even we might claim that we're mathematicians, we're statisticians, at least we're connecting with each other now. And what we could do also is basically we attend conferences that are not probably statistically related, that is a bit broad. And then we attend those conferences and we see what others are doing. Probably ideas could pop in, how some of your methods could be applied, how you could probably diversify your research or things like that. Mentorship program, I think we've talked about that a lot today, really, that I've heard a lot of people that are passionate about Africa, that they want to give back to the continent, which is good, which is great. I'm sure if each of us here would just say, okay, I want to mentor someone over there, I think that will make a huge difference. Just pick up someone and then you mentor that person if you are here. And if you're there and you know you're doing that a lot and it's a lot of work for you, I think we just want to encourage you to keep doing that, really. Collaborative research centers. Essentially, what I mean by this is basically to create like what the programs, people have talked about some programs they are doing jointly with the UK. I think these are the things that could be done, really. Cross-disciplinary teams, we should be talking to people in other disciplines so that our work will actually be. As someone spoke to us today about science communication, we should be talking to people in other fields so that they know about our models, our fancy models, our interesting models that we've developed. Continuing education and training. You should not be scared to venture. Maybe if you're a frequentist, don't be scared to venture into being Bayesian. So we should further training. You could build that bridge. You could say, okay, now I've not done anything related to finance before, but you could just start doing things related to finance. If you've not done anything related to health, try to involve yourself in projects that are related to health. And then promote publication and knowledge sharing. Be active on Twitter, be active on everywhere. At least people should be able to Google your name and say, oh, yeah, and then find you and find probably what you do there. That is very important. There are so many ways you could be active. University provide platform for people, at least for you to be visible. And then lastly, conducting reproducible research. If you develop this model, which is fine, working well, if I can't reproduce your work, I can't actually appreciate your work.
Yeah.
So we should be thinking about, as we're developing this model, GitHub is a very nice place that you can put your code there. You can put at least, even if the data cannot be shared, you can create a simulation of how, at least for people to appreciate what you've done, so that they'll be able to reproduce it and then probably further develop it or expand on what you've done. And I think that is what is actually missing a lot. That as statistician, we need to continuously remind ourselves, how do I make my job, my work visible in a way that people can actually see it, use it, and appreciate it. Thank you very much for listening. Any other contribution? I think I have 1 second.
One thing I like to mention, Olatunji, is that I think I know this is only the first day of the workshop, but one of the aims of the workshop was to encourage other people, especially non-Africans, to take part in this mission. That is to work with, at least mentor the researchers in Africa. And but looking at the list of participants today, it doesn't look like there are many non-Africans. Actually, I couldn't see. I mean, looking at the list of participants, I couldn't find any name that sounds like a non-African name.
Because it's after 5.
I know, but I know it's after 5. Even earlier today, I couldn't find any. Even earlier today, I couldn't find a name that sounded like not African. So it's kind of
there is one person, Prof. I think I cannot recall the name, but I think there is one that joined before the first break.
Yeah, but just one is too few. Too few. Man, I wish there could be. And I sent an email to Allstat about this workshop. I'm sure people looked at that email, but it seems they're not bothered. I mean, that's the kind of question I asked earlier, whether the people who are not African, do they actually care? I mean, do they actually care about wanting to help people in Africa? That's one of the questions I asked earlier, but no, it's not very clear to me whether they actually do care. Anyway.
I think on the email, some were asking what is the starting time, but there was kind of no response to the question. So maybe if you can just state when we'll be starting tomorrow in the email.
Yeah, tomorrow is the same time, Abdul. It'll be 11. Yeah,
the time wasn't stated, and people were asking what time. Yeah.
Yeah, I know, but I think it's 11:45 UK time tomorrow. Is the starting time. Yeah. Okay. So hopefully there will be more people attending, especially people who are not Africans. I mean, because we need help. I mean, one or two people cannot make a change. We Africans, we are passionate about wanting to help our brothers and sisters, but we also need help of others. We also need other people's help, and hope they do. We hope they do. Yeah.
Yeah,
right.
but I wanted to say this initiative that you've started, I think it's quite important and critical, because we also need to organize ourselves as well. In as much as, of course, we need those one, but I think this grouping going forward, if we are able to at least organize ourselves, and then of course we can find, some kind of collaboration with other people outside. But I think it has to be started, amongst us, and I think this platform that you've created, I think is quite important, and it's a good starting point. Thank you.
Thank you, Faroy. Yeah, thank you.
Oh, thank you.
Okay, guys, so have a good night. I know the times are times are different, but have a good night, and I'll see you tomorrow, 11:45 UK time. So it's the same time that we started today. So,
Okay, bye-bye.
Bye-bye.
Bye.
Bye.
Bye. Bye.
Good night.
Bye.
Load shedding has kicked in. Sorry.
Yeah.
All right, guys. Good night to all of you.
Good night.